get started. We're recording. All right. All right, everyone, we'll go ahead and get started. My name is Noel Purdy. I'm Executive Director of Healthy Franklin County, which is a health improvement coalition supported by WellSpan Health. I'd like to welcome you to the 4th annual Community Garden Workshop, Thriving Landscapes, Thriving Communities. Pre-pandemic, we would host this workshop in person at Wilson College, and we hope that we'll be able to offer programming in person throughout the next year. And we hope that we get your feedback about that and about this format. We'll be sending a survey out after the workshop, so please be mindful of that and take a few minutes to fill out the survey. To give you some background, Healthy Franklin County, as I mentioned, we're a health improvement coalition. The work that we do aligns with health priorities that are identified through a community health needs assessment. And the community health needs assessment is conducted every 3 years and is a requirement of nonprofit hospitals. And which, by the way, WellSpan Health is currently conducting their community health needs assessment. And we have like a regional footprint in the South Central region of South Central Pennsylvania. And if you haven't filled out the survey yet, I encourage you to do that. And I'll send it out after the workshop, along with some other follow-ups. So be looking for that. And through the health priorities that are identified through the community health needs assessment, we identify strategies to try and address those health priorities that are identified through the community health needs assessment. And one way that we've done that in Franklin County is that we have a task force, a nutrition, physical activity, and weight status task force. And that task force addresses increasing access to healthy and nutritious food in our community. And so that's where our community garden workshop was born out of. And we have a community garden work group that focuses on this. And so I want to take a moment to thank our volunteers who have done an amazing job of planning today's event. Diane Elsom, Julie Emig, Josh Mosley, Jessica Larkin, and Barb Houpt. And today's program is the result of their enthusiasm, relationships, creativity, and passion for gardening. So thank you to all of you. Before we get started with today's workshop, I'd like to introduce Barb Houpt, the co-chair of our Nutrition, Physical Activity, and Weight Status Task Force, and a member of the Community Garden Work Group. She is a master gardener and a community garden champion and mentor in Franklin County. Barb?
Good morning, everyone. We're very excited to have you in the program today, and we're grateful that you decided to join us on this beautiful morning. And I wanted to share with you the flow of the day, some housekeeping items, and introduce today's speakers. We do have a tight schedule this morning, but we encourage you to take breaks throughout the morning as you need to. And rest assured, we will be recording today's events, and we'll send a link to all of you afterwards. And as Noel mentioned, we do want your feedback about the workshop. A survey link will be put in the chat box at the end of today's program, and we'll also send it out to you in an email. So that we ask you save any questions you might have for our question and answer panel at the end. So just if you think of anything, jot it down this morning as you go along. So now let's get to the good part. Quick overview of our presenters. Our keynote speaker, we're so excited, is Ben Frinton from the Reed Center for Ecosystem Reintegration, and he is from Middletown, Maryland. Next is Sarah Nawa with Pasa Sustainable Agriculture, and she's going to talk about soil management and soil health. Following Sarah is Annette MaCoy with the Franklin County Master Gardeners, and Annette will talk about integrative pest management. Around 10:45, sister co-presenters, Jessica and Kelly Larkin, will talk about composting, she's yay, and vermiculture for small spaces. And Romeo the parakeet might make an appearance, we're hoping. And Jessica is with the Fulton Center for Sustainability Studies at Wilson College. Kelly is a worm enthusiast who happens to work from DreamWorks, and today she is joining us from, I guess, sunny California.
It is still a little dark, but
well, true, that's
we're
right.
getting there.
There's behind. Sorry. Thank you for getting up for us. And our last presenter is Julie Emig. She is a retired music teacher and garden enthusiast, and she's going to share with us the joys and challenges of foodscaping in small spaces. So without further ado, let's get started with our keynote speaker, Ben Frinton.
Hi, everybody. Thank you so much for this opportunity. This is something that, for the last few years now, I'm used to doing speaker circuits and traveling around the world and having an opportunity to speak to different groups. And those opportunities are much harder to come by these days. So this is so much of what gives me my life force to keep doing the work that I'm doing. So I'm gonna share my screen. Please, if one of you could give me a thumbs up once it is up, that would be great. Okay. Are you able to see it? All right, perfect. So essentially, I'm going to be speaking rather quickly through some of these sections because I don't want to be redundant to some of our other speakers, but I did want to express why it is that I do the work that I do, what inspires me, and hopefully it's something that all of you can find something in to take with you, to really revel in awe that is the natural ecosystem and what it's capable of. And then most importantly, how we can tap into what nature is capable of to actually meet our own needs. So I'm going to go through this next slide very quickly. I was born in Maryland. I was a speech writer, teleprompter operator, and speech coach for 10 years in Washington, D.C. and around the world. I co-founded a nonprofit called Can You Love, which you'll hear a little bit more about later. And I patented these very easily replicable vertical gardening systems that you'll see a few photos of. I joined Forested in Bowie, Maryland in 2014. It's now 15 acres. It was about 10 acres at the time that I was working on it, which is a really beautiful example of a suburban food forest in a very densely populated area. I've spent about 10 years now consulting and holding educational seminars and lectures around the world. Excuse my voice. Seems like I'm losing my voice a little bit. In 2018, I had an opportunity to move to Morning View, call it Morning View Food Forest. It's a 150-acre farm in central Maryland, just west of Frederick in Middletown, Maryland, and it's the current headquarters for the Reed Center, which you'll be hearing more about. And so I wanted to kind of dive in here and talk a little bit about the perception of human beings. And I love to start with this really simple question. I want everybody to picture their favorite plant. Mine is a fig. Fig trees are absolutely amazing. In tropical areas, they're considered mother trees for most oases and forests and jungles. And so if everybody's pictured your favorite plant, how many of you pictured the roots of that plant? So I've been doing this, obviously, in this setting. I can't really see how many people are raising their hands, but I've been doing this for many, many years. And I've only had a handful of people out of the many thousands of people actually raise their hands. And the reason is simple, that roots are not actually within our visual acuity. We can't actually see them so easily. The few hands that people did raise, all but one of them, their favorite plant was a carrot, a beet, or another root vegetable. So another thing that I wanted to point out is that there's all kinds of organisms around the world that live in our environments that we hardly see. And one of my favorites, and basically the theme for my talk today, is around lichens. Lichens are extremophile of extremophiles. And what that means is they can live in extraordinarily difficult environments. And despite what a lot of people think, these are not organisms unto themselves. These are actually a community of organisms. Lichens are defined in many texts as fungi and algae actually combining to create this superorganism. And that's actually what we've been going off of scientifically for a very, very long time. And there is some truth to that, and I'll get to that in a second. But what's really interesting, now that we have the ability to test the genetics of different, the DNA of different organisms, we have yet to find a single lichen anywhere in the world that is strictly a fungus and an algae. It can be multiple fungi, it can be, there's often yeasts, many different colonies of bacteria, nematodes. There are all kinds of organisms that are living in this form. And what it allows them to do is live in places and in circumstances that none of the individuals would be able to survive. And there's a woman from Montreal, or maybe Toronto, actually, I think now, Natasha Meyer, who coined a term. I'm guessing it's existed in many different circles, but she was the first one that brought it to my attention, which is involution. It's a concept that I think actually it's definitely shaken the foundation of how I see the world. When we look at lichens and the areas in which they are able to thrive, lichens are taking the attributes of the different organisms that are part of this superorganism and allowing them to, for example, create enzymes to extract food from rocks or from bark, to hold moisture in areas in which moisture is extraordinarily sparse. And the lichens that we see, there is historical evidence for millions of years, hundreds of millions of years, and some estimates. But what's really interesting, in 2014, there was a Harvard study in which they took fungi and algae from different environments all over the world and put them in petri dishes in which they gave them very extreme environments, whether that's food supplies, temperatures, things that they knew that neither of the organisms would be able to survive on their own, and they lichenized before their very eyes. I mean, that's a pretty extraordinary thing. Now, they said that they don't look nearly as neat or as refined as the lichens that we see in our environment, but nonetheless, because these two distinct species are able to create this partnership, they've been able to find lichens in all kinds of places, like the poles, like in mines that are miles beneath the surface of the earth. There's a bunch of assumptions out there that lichen might have been one of the organisms that could have landed on Earth sometime in our very distant path, surviving, say, on the inside of a meteorite. We do know that they can survive space conditions. There's all kinds of lengthy decade-long experiments in which they have shown that they can clearly survive in space. It's just entry into Earth that would not be survivable unless they're inside of something that would protect them from that. So for me, just the recognition that our bodies, the human body, is not just the human body. we are a superorganism as well, that our body is actually profoundly more microbial. We have 9-to-1 microbial cells comparatively to human cells in our body, that we have this relationship with all of these organisms in the same way that our ecosystems do, where, in fact, all of our ability to digest, maybe not the simple sugars, which can be digested in our stomach acids, but the vast majority of what we digest from healthy whole foods is us redigesting what microbes are actually breaking down in our gut. And so if it wasn't for these microbes being able to break down and for us to be able to digest what it is that they break down, we would not be able to be us. And it goes much deeper. I'll get to some really cool examples of how we know microbes actually dictate, for example, our decision making. But now I'm going to dive a little bit into something that's a little less fun, which is modern agriculture, just to kind of show how far we've come from the natural ecosystems in which all of our ancestors thrived and lived for the bulk of human history. And this is a basic breakdown of the biomes on the planet. It's a very rough one because, the reality is that there are gradients in between these different ecosystems. But nonetheless, I think that this is a helpful way to look at it. And agriculture now covers, in some estimates, up to 41% of the Earth's landmass. And most of that agriculture is, of course, happening in what was forest and what was grass and savanna lands. And obviously, we're running out of space in which we can continue to grow agricultural, let's say, commodity crops, or growing in industrial ways. So what I'm going to do is take you on just a really brief journey of, let's see if I can make this play. There we go. A really brief journey of how it is that we design landscapes. So this was the Great Prairies of the Midwest. And you can see all of these squares. We've basically turned the entire Earth into an Excel spreadsheet. And that Excel spreadsheet allows for us to be extremely efficient, both economically efficient, but also efficient in the amount of labor and developing models on what we can expect to get out of a piece of land. And we've basically turned this entire area into a massive corn belt. And the vast majority of it is for animal feed, and then some for ethanol, and very little for actual human feed. So you can see how this ties into, I'm going to pause it here, how this actually ties into the Mississippi. And it's, I'll just briefly say here that when you think about the percentage of corn and soy that is being grown and how much pesticides are being sprayed, and particularly glyphosate, among many others, just because we were able to figure out in a laboratory where we were able to remove, scientifically able to remove the variables to show that these pesticides do the very specific things that we want to do, we've never been able to test at scale what would it do if you're using tens of millions, hundreds of millions of acres of land around the world and spraying in bulk these kinds of chemicals. And it connects all the way down into this massive dead zone in the Gulf of Mexico. Now, most of that corn is growing to different feedlots, and you'll see this is now where we're moving into desert agriculture. This is in Arizona and in Texas, where you see these circular pivots. In fact, this is also happening in Saudi Arabia. It's happening in Israel. It's happening across the Middle East as well. And the bulk of these circle pivots that we're growing in deserts around the world are to grow alfalfa, again, for animal feed. And those circles are made, for those of you that don't know, by a central well with a pivot irrigation. Basically these bars, you'll see a picture of it, that actually spin in a circle, continuously irrigating in the middle of the desert. And in fact, some of this land that's being put into alfalfa is being shipped around the world. Some of this land is even being leased by Saudi Arabia and Israel and others to feed what is a growing meat habit around the world. So within that, we have these extensive feedlots where we are feeding cattle the corn that is shipped, as well as the alfalfa. And the reason why I'm pointing all of this out is that every single thing that I have mentioned, corn, soy, alfalfa, and cows, bovine, all of these creatures existed in an ecosystem at one time. But for the sake of economic efficiency, what we have done is we've separated out all of these component parts and placed them in different places around the world, that we can put all of the infrastructure for, say, beef production, all of the infrastructure for dairy production, all of the infrastructure for corn production. And this is the economy of scale that a lot of us have heard about. The problem is that what happens when you have an Excel spreadsheet and you start putting in too many factors, you start getting error messages. And this is where the externalities of the systems that we have created don't have room in being accounted for. So I'll just, quickly go through some examples, like the kinds of erosion. You can see this little line right here, about 2.5 to 3 feet down. This is happening across the entire mechanized agricultural world, and this is called plowpan, and it's caused by the weight of tractors on land. You can plow so deep, but the weight of those tractors, and particularly where I live, that's right where our clay layer starts. So it's actually even more intense. What that causes is, particularly in a hilly landscape, when water flows through that plowed area and it hits that plow pan and it's on a slope, it doesn't have any room to go down. So it's going to move laterally. And once it starts moving laterally, especially in big rains, that's when it gets the momentum to actually start carrying massive amounts of soil. So water erosion is something that most of us know about. Now imagine how different that these ecosystems would have been in the Midwest, where we're seeing such massive erosion problems, when these prairies had root systems that would go down, some as far as 35, and I would bet much deeper. But this is from the Botanical Gardens in Washington, D.C., just showing different kinds of prairie grasses and the lengths of some of their root systems. Now imagine further how, when in the middle of a drought, opposed to having roots that only go down 1.5 to 2.5 feet deep, how much better adapted these perennial grasses are to being able to survive things like a drought. Now take it a step further, fires, which were a very common experience of these ecosystems, that these plants have root systems that are able to survive massive fires as well, and just resprout and grow. And we have to remember that, when we have these kinds of ecosystems, you can see the brown, right? So when these plants do experience, say, their fall, winter, dormant months, and you have all of this brown mass sitting on top of your soil, that shade during the non-growing months and its ability to actually retain moisture, that these roots are paths of least resistance for water to get deeper into the soil. These plants are, I know it's ascientific to anthropomorphize, but they're brilliant. They know how to survive. They've been doing it longer than us, and they create micro ecosystems that allow for them to thrive, to survive for the long haul. And we've basically worked that out of the system by relying on annual plants as the vast majority of our diet. Annual plants are amazing. I'm not trying to dismiss annual plants, but we have to understand that annual plants are extremely rare. If you take the full sum of all of the biomass of plants on Earth, they're extremely rare in terms of the amount of biomass in nature. The only places in which annual plants thrive and dominate ecosystems are in areas in which there are regular, massive natural disasters, such as floods and very, very heavy fires. And that is the story of the three most common plants that we have planted on Earth, which is wheat, the #1 grown crop on Earth, originated in the Fertile Crescent. At least the mass production of it originated in the Fertile Crescent, where you had the Tigris and the Euphrates flooding, massive floods every single year, bringing new silt with it, so new nutrition, but most importantly, wiping out any other competition that would grow in that area. And they would plow through that crusty top and plant their wheat in that ecosystem. Rice is a floodplain plant. Now, many of you guys have seen those beautiful flood terraces that go up into the hills in Tibet and things like that around Asia. That is just them taking a flood that would just be happening in the valley and extending that flood all the way up the hillside. And I've been to China and the artificial floodplains that they've created for rice all up and down the east coast of that country. And so what we have basically done, and corn, by the way, originating in Central America around both flood and fire. And so what we have to do, agriculturally speaking, to mimic what those natural disasters do is we have to mimic natural disasters. We do that by plowing around the world. People burn their agricultural fields. And now the newest technological advancement is to spray herbicide, because these plants, the reason why they produce as much grain as they do is because naturally in their ecosystem, they have to produce as much grain as possible, so that that following year, when other plants start moving into the ecosystem they're currently occupying, that hopefully some of those seeds find places that that are barren pieces of ground in which they can thrive, because they can't outcompete these perennial and biennial plants, and can't even compete many annual plants. If you take one of these cornfields that are in my valley around me, which are right now completely barren with cover crops that are like an inch long. But you take that in an entire cornfield and let every single kernel that grows hit the ground in that ecosystem, and you do no landscaping, the likelihood that next year that corn will grow is pretty minimal. Not just because they're hybridized or GMO or whatever, but because of the amount of plant biomass that starts to grow up in these fields very quickly. So another form of erosion that is happening a lot more these days that people don't really hear much about on the East Coast are that the dust bowls are returning. This is Phoenix, Arizona. That's a mile-high dust storm. They're happening on a near annual basis in the month of July. And unlike our grandparents' dust bowls of the 1930s, these are actually not just soil, but they're also all of our agricultural additives and pesticides in the air. And we just don't know, being in a world where we have so many variables, we just don't know what the impact of that is.
Ben, this is
Yes, ma'am.
Noel. Just wanted to give you a 15-minute.
Yeah.
Yeah,
Thank you so much.
you're
Appreciate
welcome.
it. So this is a tool that I wanted to share with everybody. For those of you that have not seen it, Google Earth has an engine called Google Earth Time Lapse. It is the most important thing that I will be sharing with all of you today. And I hope that all of you take the time to go look at it. It doesn't feel good, but this is an objective look at what we have done with our collective decision making to the surface of the planet since 1984. It works just like Google Earth. You can't quite zoom in the way you can on Google Earth, where you're like, oh, that's my mom's old car. But you can see at a regional level the shift since my year of birth. This starts in 1984. And I just wanted to share with you a couple really poignant ones. This is in the Amazon. The dark green that you see all around is this profoundly dense, radically diverse forest that we are all reliant upon, but yet have created to create a spreadsheet to show the economic value of adequately. And all of this you'll see starting to grow. You see this dark green turning into light green. The light green is soy predominantly. And these brown spots are Kobe beef, Brazilian beef production. And so because we do not have models that adequately express right now how these things are profitable to us, we do have spreadsheets that show how soy converted into beef are profitable. And this is something that it's really hard to look at, but we can actually go around the world and watch the fourth largest lake in the world dry up, the Aral Sea. And you can zoom in and actually see the causation, direct causation. You don't have to deal with whether somebody believes in climate change or not. I honestly, this might be controversial. I don't care if people believe in climate change. We need people that believe that we are about to run out of water, and that we need to change the hydrology of the land back to what thriving ecosystems allowed it to be. It's those thriving ecosystems and the profound water holding capacity that allowed civilization to take place in the first place. And right now, 1 in 10 major rivers are no longer reaching their end. And we're running into a situation where the aquifers that we rely upon in the Central Valley of California, the Oglala aquifer in the Midwest, are being depleted at such a rate that now the water that we're drawing up out of those things are actually high in salt, which means when you irrigate using high salt content water, requires even more irrigation to irrigate that same amount of crop. So with that, here's another one that I put together. This is Las Vegas, this fastest growing city in the United States over that time. And you can watch the city grow. You can actually zoom in and see all the golf courses and huge water features and the Venetian Hotel be built and like all these amazing, architectural and, aesthetic feats. But this is me pausing and I'm going back and forth between 1984 and 2016. It now goes to 2020. I haven't made any new videos. But now I'm going to zoom out and we're going to look at the water supply feeding Las Vegas simultaneously as the growth of Las Vegas is happening. So you can actually watch the water receding, and it's tough to understand scale, but you can see scale here. This is 5 miles in scale here. So that's about 5 miles across right here. What we're watching is quite literally scores of billions of gallons of water that are lost. So this is where I'm going to start getting into some of the more exciting things, what we can do about it. Hyper-localized, perennialized, densified agroecosystems. It sounds like a lot of jargon, but I think that much of what this community is talking about here is how it is that we can relocalize food systems, which has precedent, I'll talk about, where we can grow more perennial plants that actually feed us as well. That's how I got into this work. I saw the reforestation work that I did just get cut down within 6 to 8 years, because you can't go to places where people don't know where their next meal is going to come from and say, hey, in 20 years, it's going to be really good for your environment. You have to grow perennialized ecosystems that actually meet human needs. Densified, that speaks for itself, agroecosystems. So the victory gardens of the 40s and 50s was a massively subsidized program because for our war effort, a term that wasn't coined then, this was absolutely vital to the homeland security of the United States to keep food prices down. And in fact, once they started doing the training and providing the seed and all these kinds of supports, by 1948 through 1953, a couple of those years, more than 50% of the food that was consumed in the United States came out of these victory gardens. And so they used all these like really fun ways to get kids involved, and school gardens. Who would have thought school gardens would be an important feature in relocalizing food systems? So this was my first foray into really trying to go into densely populated areas and go into slums and refugee camps where I did a lot of work, and figure out ways in which we can grow as much food as possible in as healthful a way, and with an added component of needing to grow independent of the ground, because so many of the most exploited and impoverished areas have very little sanitation. Kibera slum that I worked in had one toilet per 300 to 3,000 people. And just because there's a toilet doesn't mean that it goes down into a nice sewer septic system, right? So whenever it would rain, you would have a scenario in which there is massive microbial runoff that actually was a mind-blowing moment, that starvation is not just a lack of food coming into your body, but also parasitic bellies that are consuming the nutrition that kids do eat. So I also built these growing walls. I don't have a lot of time to go into the mechanics of it, but they're very simple. This is my 96-year-old grandmother-in-law who was able to grow for the first time since she was in her 70s, because she can't do the kneeling and the back-breaking work that she was doing before. It was just so wonderful to see her to see the life that it brought back to her, the purpose that it brought back to her in her last years. Going back to densification, when we're looking at a cornfield and we're utilizing about 18 vertical inches of where you can harvest food from across 100 acres, 1,000 acres, scale up to 100 million acres. Apple orchards, this is a perennialized system, but still we're only harvesting from about 6 vertical feet, typically, using dwarf trees in our apple orchards. And in both of these systems, all of the plants have all of the same needs all at the same time. So this is what monocultures are really amazing in being as economically efficient to harvest. But in terms of what they do to the soil, it's a mining process. Our modern agriculture is a mining process, whether it's taking water and shipping it around the world, whether it is the nutrition, where we're taking the most nutrient dense components of a field off of it every single year and shipping it elsewhere. That's not how nature works. Nature has diversified yields all at different times. And different plants have different needs, and different plants have different excesses that they then share back with the ecosystem to support other plants that have those needs. That sounds pretty radical, but if you can look up Susan Simard's work, which I'll show you very briefly, Susan Simard was able to show just a very minuscule window into the sharing networks that exist within thriving landscapes. So just to kind of show you an above ground view of what you can harvest from corn, what you can harvest from apples, and what you can harvest from a diversified system. So forest agriculture, agroforestry is a fraught term because clear cutting is also considered agroforestry, or eucalyptus plantations for paper are considered agroforestry. But food forests and forest gardens, they don't have to be starting at 100 feet or 120 feet. They can start at 10 feet and work their way down. I've done that on little postage stamp yards where you're maximizing the use of sun by tucking trees. You start with your biggest trees and work your way down to your smallest and herbaceous plants. And then you take advantage of these shady areas by growing mushrooms and shade loving crops, plants, animals, things like that. You can really maximize your growing potential and get diversified yields. And in fact, in these systems, I'm not going to lie, yeah, they require a lot more effort than one guy on a combine harvester, but you can produce at a minimum 20 to 50 times the kind yield of what you can get out of our modern agricultural systems. So
I just wanted to give you a heads up, 3 minutes.
Yep, understood. So this is my work at Morning View Food Forest. It's a 150 acre plot that this beautiful family found out about the work I was doing and gave me the opportunity to manifest my dreams and gifted this space to what is going to be more than 660,000 perennial plants. We are by June of next year, we will have planted about 37 acres of food forest. Right now we're at about 5, and we have massive tree plantings coming up this spring, which I'll show you in just a second. This is our Tree of Life project, where we have this, it's basically for the scalability of radical polycultures, everything that you harvest in February, March, April, May, June, July, August, September, October, November. And I just wanted to say that community is the rule, not the exception. And this is just one 100 meter by 100 meter area of one tree species sharing resources with using fungal networks that connect all of these plants. And the oldest trees in the ecosystem are the most connected trees, not just sharing resources, but also sharing information within that system. I don't really have time for this, but I wanted to show you this video to show that this is not unprecedented. This is an uncontacted tribe in the middle of the Amazon. And this Dr. Morellis is flying around with high-powered lenses to show that these people exist so that the mining interests that say they don't exist can't just commit genocide. And what I wanted to show you is the way that they even found these communities is that there's a depression in the forest. Oops, oh no. There's a depression in the forest where you can see that they've planted this radically diverse food forest all around their community. And in fact, the ecosystem in which all of you are, and me, even the Kelly who's in California, all of these were perennialized massive ecosystems. Here it was the chestnut where Kelly is. It was these giant oak trees where they had 10-year storages of 10-year supplies of oaks, of acorns, to ensure that they had long-term sustainability of their food supply and their ecosystem simultaneously. So here are our spring planting days. Please connect with us. We have a concert on Earth Day. We do yoga on Wednesdays and Sundays. We have silent retreats. Thank you. I know I spoke quite fast, and that was a lot of information. I will gladly answer any questions that we don't have time for in our Q&A session, and would love to be able to help in any way I can, help you visualize what your agro ecosystem, your backyard, how it can be a refugee camp for wildlife and for community members. Stop my share.
Excellent. Thank you so much, Ben. All right. And as Ben said, save your questions. We'll be reserving those for the Q&A after all of our presenters have made their presentations. So next, we have Jessica and Kelly Larkin with our vermiculture and composting presentation.
All right, so thank you all for joining us today. Can you see the screen? Yeah. All right. So basically what we're going to be talking about today is ways to turn your food scraps. Sometimes they call this food waste. I would argue that it's not waste when you turn it into something absolutely incredible and beneficial. And then we're going to talk about also how to do vermicomposting, which is composting with worms. So today we can see that I have a couple of stats here. Food waste contributes to about, yeah.
Yes, sorry, just want to let you know that the screen share that's showing is the notes, like sort of, not the notes, but like the back, sort of the, yeah, it does have like the next slide. It's like dual images.
Yeah, let me see if I end. I'm not very good with technology. Maybe if I do from current slide.
Yeah, try from current slide. Or if you have two screens, I'm wondering.
Yeah, I don't know.
Maybe try from beginning.
Yeah.
Okay. Huh.
Display settings.
Swap, there, swap presenters view and slideshow.
We did it.
There we go.
Awesome. Thank you, collective group, and thank you, Noel, for letting me know that.
Yep.
Okay, so basically here's a slide that just says, you know, like our food waste contributes to 11% of the world's greenhouse gas emission, which is a lot. And about 1/3 of all of our food produced around the world is actually wasted. Here in the United States, we discard about 8 billion pounds of food every single year, and that is a lot. Okay, so where does this come from, right? You know, we live in a very complex, multifaceted system, so it comes from many different places. However, a lot of our waste, our food waste, comes from our homes, and nearly 40 million tons, which is about 30 to 40% of that is also from the waste comes from our food supply. So when we look at where food comes, our waste comes from, it's multifaceted. But when we look at what can we personally do, right? We can actually on an individual level make an impact. The average person wastes about 1 pound of food a day. And that actually equates to a lot of money, right? It's about $1,600 every single year that we waste. So what can we do to prevent this from happening? We can absolutely recycle. There's a lot of food recovery programs, but we can also compost at home. So here we go into learning 2 different ways that we can turn our food scraps into compost. So the beautiful thing about compost is we're returning what came from the earth back to the earth. It's going to reduce, when we compost, the amount of food waste going into landfills, and actually 22% of the space taken up by landfills is from our food. That's a lot. By turning food scraps into compost, we also reduce the amount of methane emissions that are coming from the landfill and going into our earth, and therefore we're also reducing our carbon footprint. Compost is a fantastic soil amender. It is not a fertilizer. So an amender does more than fertilization. It actually speaks to many different things. So the compost is gonna enrich our soil, and therefore it's gonna help with moisture retention. It's gonna encourage beneficial bacteria and fungi that will also help break the organic matter into humus, which then feeds the whole entire food web. What this results in is a happier soil, which is happier plants. And also, if we use this compost for plants that we grow for food, it will actually make us healthy as well. So compost really kind of breaks down into 3 different types. You have aerobic, which when you think about what is that, right? It's these bacteria that really need oxygen to do their job and to thrive. Think of when you're doing aerobics, right? You are actively moving your body and you need air to continue to move. So that's how I like to remember aerobic. Anaerobic is the opposite. It's bacteria who doesn't need air. And another way, which we'll go into later, is you can compost with worms. Now, all these different ways of composting require oxygen, they require moisture, they require materials, and then temperature as well. And within the system, you have fantastic microorganisms, such as bacteria and fungi, that break it all down and are doing the work for you. So what oxygen does is it keeps your fantastic microorganisms alive. You can compost just by using a cold pile, which you just pile everything up into a single pile and it sits there. You can also do composting where you turn your pile about every 7 to 10 days. That fluffs up the material and adds oxygen. And what that does is speed up your decomposition. I highly recommend that way. You get your compost faster than doing a static pile. Another important element is your moisture. So microorganisms like us need water to survive. And what Text you're going for is basically like a wrung out sponge. You can open up your compost containers and allow the rain to come in, or what you can also do is just add your own water. So your compost is also is going to need materials. So this is going to be your food scraps. It's also going to really definitely be needing this brown, which is your carbon. These things are your dead leaves, your branches and twigs. So as the leaves fall, you can add those to your pile. As trees shed their branches and twigs, you can add those to your compost material. And what this does is it provides energy for your microorganisms to start to do the work. Another really important addition to your compost materials are your greens, and these add your nitrogen. So what these do essentially is feed your decomposers. And these are your grass clippings, your vegetable and food scraps, your coffee grounds. And these 2 things together at the right ratio, which is I recommend, and a lot of other people, a 2 to 1, so that's 2 browns to every 1 greens. This creates the bulk of your material that then, with the help of your incredible heavy lifting microorganisms and bacteria, all of these guys will turn your food scraps and your lawn trimmings into a useful product. So, and I'm sorry if I'm going really fast. We have a limited amount of time, so it's kind of like I've never done speed dating before, but this is a little bit like this, where I'm going to kind of shoot through all these things, but hopefully gives you a good overview and pique your interest, so that way you can either do some research on your own. I'm also happy to help in any way possible. So one thing that we need to I put this slide up here just so you can see different types of greens and brown items, as well as the really important, do not put these into your compost, especially your home compost. They will cause, they will spoil your compost. So don't add things like meat or fish or heavily oiled products. Any type of pet manure is also not good. Harsh chemicals, obviously you don't want those to go into the land and also end up in your food system. So you want to keep those away as well. But let's see, and then also, as again, like this whole troubleshooting, if you notice your compost is kind of smelling bad, or you're not getting the proper breakdown rate, you just need to really troubleshoot. So have you been turning your pile every 7 to 10 days? Perhaps put a timer on your phone, put it in a calendar. It becomes a cycle, but as life carries on, we tend to forget about things. So just help yourself out and put a little timer on. I find that's really helpful for me. So are you turning your pile? Are you adding, is it that beautiful kind of wrung out sponge consistency? If not, just add more moisture. If you have a bin that turns, which I'll show you a picture of, are you spinning it twice a week? Did you forget about it? So the beautiful thing about all this is that really you can, when you notice something going wrong, you can fix it. And that is a beautiful thing. You just have to remember it's part of a system. And if there's something in the system that's breaking down, you can just notice and then fix it. So here I have a slide that shows you kind of 2 different ways of composting. These are the pros and cons of each. And really, I want you to take a look at your land and decide what maybe, like, is a bin better for me? Is a pile better for me? Do I want to try both? I don't think we should limit ourselves. Seeing different systems in action is actually really rewarding. So when we look at bins over here on our left-hand side, these are just some examples. At our house, we have this top bin, which is essentially just a trash can with holes that were in it for aeration. When the compost is kind of decomposing, you get some flies and critters in here, which the worms then worms come in and grubs come in, and the birds we have seen like plucking them from the side, so it actually becomes a feeder in itself. This is a tumbler down below. I really enjoy those. So let's just get into the pros and cons. So the best thing about bins is that if you live in a small piece of land, this is an incredible resource for small spaces. The downside of that, it's not adaptable, where a compost pile, as you see images on your right here, you can really scale them up to any size. Your bins also make it very difficult for pests to get in. That doesn't mean they will not get in, because obviously there's foods, it is a food source, but they do a much better job than, say, these open piles where it's like a free-for-all buffet. Bins also really restrict odors, which is fantastic. Now, when your compost pile is going, it shouldn't smell, but it might, like if something is off, it might smell. But so one good thing is, if you're kind of worried about this, I would go for your bin. Bins are relatively low labor. You simply add your materials and water and turn it around. Some you don't have to turn, but others you do. So when looking at what type of bin you're going to get, really just kind of take a look at what is that bin specific need. So what we do is we turn our bin, or we try to, because we're humans. We don't always manage to do it in a timely manner, but we try to turn it every 7 to 10 days to get that air into the bin itself. Bins are relatively low labor. Compost piles, you really should turn them every single week. They tend to be bigger, which is why they're higher in labor. The benefit of your pile, though, is that in a very short amount of time, you can see here I have a note, a hot pile, which is one that is turned consistently every week. You really get compost in 3 weeks, which is such a short time in life. Bins, however, because it's smaller and just the type of system it is, it typically takes about 3 to 6 months to produce usable compost. You can see here I have a cost range that I saw was about $50 to $150 for purchasing a bin. A compost pile really is kind of whatever materials you have and whatever system you want to go for. That cost will fluctuate, but you really can make it for nothing at all. So again, just kind of thinking, you say, hey, I'm interested in composting, kind of look at what your own backyard is like, what your own desires are, and make a decision based on that. I really wanted to share this idea with you. I thought it was a really cool system. This is a keyhole bed, so it's a keyhole because you can walk in here and it's this little circle. It creates very easy access to plants, but this African keyhole bed, actually right here, you can see they put a compost bin. So they pile their browns and greens in layers, turn it around. It's feeding the soil as it rains, and then you can actually plant into this, or you can just heave this up and create a new bed. So it's just a really cool option that I saw when doing some more research. All right, so I touched on this a little bit already, but here's just a really great infographic that kind of tells you, okay, so my compost is smelling, what can I do to fix it? Thinking about, well, is it too wet? And you test to see if it's too wet. If it's dry, you add water. Have I actually turned my pile? When did I last turn it? If it's smelling, just turn it again. You might need some more grass clippings. You might need some more brown. And then again, remember, like, did you accidentally put some undesirables in there, such as meat or highly oiled products or dairy? And if you did do that, you have the option of, I personally would remove it. And again, do not panic or expect your compost pile or bin to be absolutely perfect. This is part of a system, and the more you get composting, the more you'll get used to, kind of going through the rhythms of the compost. What we do is when we add food scraps, say we add a compost bucket of food scraps, then I'm going to add two buckets of browns into my compost pile. So you can have a really helpful measuring system as well.
Jess, just wanted to let you know it's 10:02.
Okay, thank you, Noel. So my sister and I are now going to speed through. She is an excellent worm farmer, so she's going to help me in this part. And we're going to speed through, unfortunately, one of my favorites, which is vermicomposting, which is composting with worms. So these two are the red wigglers and the European night crawlers are the worms that we typically see here in composting. Red wigglers are very durable and they are a powerhouse when it comes to eating. They're probably my favorite worms to use. European night crawlers are also very, very good to use. And if you're enjoy fishing, this too is, you can use them for bait. Click. All right. So these are some examples of bins that you can use. Google search will definitely show you many different options. I have a current bin system over here going at the moment, and mine is an open system. So I took a plastic tote, put the worm bedding and the worms in, and it just stays open like this. This system, however, you have to train your worms to stay in the bin. So at the night, during the night, you have to keep your light on for about 1 week, and then the worms learn not to come out and they stay in. My sister, she will talk about her stackable worm condo, which is probably my favorite. And Kelly, would you say yours?
Yeah, it's really easy to use and just a very intuitive design, and I don't need to train my worms to not escape.
Which, let me tell you, on like the first and second night, we had giant worm escapes. So 2,000 worms crawling out of a bin and onto your floor, and then having to pick them up is an experience all in itself. But it was, I don't know, it's a story to live on. Some other bins that you can see is like you can have worm beds. These are typically outside and really large. And then you have these flow through systems as well. Yeah. So Kelly's going to take it away from here. I'm sure you're sick of hearing my voice, and she's going to talk to you about her incredible stackable system.
So right here we have kind of a layered view of my system. The way you use the system is it has multiple trays, as you can see, and you add food products to the top trays, and the worms will process them. They will move from the bottom of the tray up. And once they're in there and they're doing their work, you can take the bottommost tray, remove the compost from that, and place it on the top. So you have a new top tray. So, it's an eternal cycle. It's also a great way to see the worms at work. So if you see my top tray, this was a lovely week where I ate a bunch of avocados. What a good week, right? And I mixed it in with my brown materials, so the leaves from the gardening that we're doing. I have a few of the brown paper bags that I might have gotten while shopping. Then you can see the middle tray. It had the same content as my top tray, but you can see that there are a few items that are more difficult for worms to process in a quick manner. So we have eggshells. We also have this beautiful bundle of wildflowers that was at the end of its life that I removed. So those items are still in the process of composting, but you can tell there's a palpable difference between these first two trays. And last, we have one of my bottommost trays. The only things that are still left in there, we have a few eggshells in there. Those take a while to break down, but they are nice to have because they are still a source of food for our worm friends. So I'll typically leave some eggshells in there and even add them to my garden. So the worms that do exist in my garden have a little snack for later. I took just a handful of dirt from my center worm bin here. You can see a little worm friend in there. You can also see an egg. So just in the handful that I got, I managed to also find a worm egg. So not only are my worms, living their lives and eating, but they're also reproducing. So I have a self-sufficient system here of worms just, enjoying some delicious food scraps and being friends with each other and continuing their lineage in my worm bin.
And one awesome thing is you can see down here at the bottom, Kelly does have a thermometer. This is great for both worm composting and for your home compost garden. You want a nice range of about like 140 to 160, and between that is a really great sweet spot for compost at least. I can't remember what the worms need.
For worms, it's a little cooler just because, worms are living organisms. So their temperature tolerance is a little lower. You can't see it on here, but this thermometer I have actually has cute little graphics on it of like showing the worm's ideal like activity window where they're most active. I think you want to avoid, below freezing, obviously, the worms will die. And you want to avoid, I think, above 110 degrees because the worms will die. So in between those areas, the worms have different levels of activity. So on a nice warm, spread of time, they're going to be doing a lot more compost work than if it's colder or too hot, where they might remain dormant to save some energy.
Beautiful. Okay, so here's just a slide that will show you kind of the different places that both Kelly and I get our things from. The system that Kelly has is this Vermitech, which is awesome. This is the most up-to-date version and has some cool features. And you got your worms from Worms for Earth, right, Kel?
I did. They came happy and healthy in a little bag that said live worms on it. It was
which is super
really
exciting.
Great. Yeah. Nothing is better than getting a
It's
bag in the
fantastic, like,
mail
we
that says
received
live
worms in the
worms.
mail. And then this is, so for us in Pennsylvania, Uncle Jim's Worm Farm has been doing their worm business for, I think, 25 years now. It's in Spring Grove, PA, which is super local. And it's always great when we can support a local business. They're great resources for information. And yes, the worms that I receive also have come in a cute little bag that it's and they're all happy and healthy. So these are some books too that I also recommend if you're interested in these topics. The internet is also a great resource, and there's some great worm and composting enthusiasts out there that make it really fun. Fun and exciting. All right. Kel, do you want to go over the feeding worms?
Sure. So worms love a lot of the same foods that we enjoy. When I'm preparing a meal for myself, I'm also preparing a meal for my worms. I will chop up any of my produce very small. Sometimes to give your worms a boost, you can also make, a produce smoothie where you actually blend a lot of your materials together and integrate it into the soil. That way, there's more surface area and your worms will be able to break down that food faster. Fruits and veggies, coffee grounds, filters, tea bags, all really great things. I do want to talk about coffee grounds and their purpose. Worms actually have a very interesting digestive system, and they use something called grit to essentially push the food through their body and grind it down to be smaller. If you're a coffee drinker, you've solved your grit problem. I do not drink coffee, so I need to introduce grit in other ways. Cornmeal is a great way to introduce grit, but something that I do is I will use my eggs as my grit, and that is a great thing to do because it's also a pH stabilizer, considering the amazing qualities that eggshells have. So once I've finished using an egg, I'll just bake it in the oven. I'll bake the shell in the oven for about 20 minutes at 350. And once I have a good collection, I'll put them in my spice grinder and I'll make, that egg powder. And every once in a while, when I'm adding my materials, I'll just go ahead and sprinkle some grit on. It helps the digestion process of the worms and it's very good for them. But you don't need to worry about that. If you are a coffee drinker, it will do the exact same thing. So rinsed or cooked eggshells are really great. Sometimes I'll find my worms just all hanging out in an eggshell together. So not only is it a great, food, but it's also apparently a really hot hangout spot for your worms. They like to be in there. But it is very similar to composting. You want to make sure you have your balance of brown and green matters. And once again, worms are pretty much vegetarians. They like eating, the small microorganisms that are eating away at your food. So no meat, bones, dairy products, treated paper, anything with chemicals. Those things are just going to leach back into your soil and, create a detriment for your ecosystem.
And I just put on the side here just some kind of metrics. So it takes 2 pounds of worms, 24 hours when your worms are really cooking and going, to eat about 1 pound of food scraps. So kind of looking at that, it's pretty amazing, right? When the average human kind of wastes about 1 pound of food scraps. These guys are a fantastic way to divert waste. And they're also really fun to watch. You will really get into worms. They become family members. At least for me, I enjoy checking on them. Yeah, and like Kelly said, seeing where they're hanging out that day is really fun. So we're going to go over now kind of, the friends and foes of the worm bin. You will have visitors. There's no reason to panic. There's always a solution. And it's also another reminder, like these guys, just like us, are part of an ecosystem. You are not just a worm farmer. You are farming with many other friends and perhaps foes. So let's see, Cal, what have you seen in your bin really?
My biggest, I don't want to call them a nemesis because, you know, they're just trying their best like everybody else, but I've had a lot of soldier flies in my bin. They are both a friend and a foe because too many of them can create an acidic environment, which is very detrimental to the worms. But if you have a lot of compost, they are a great help because those guys, you can watch them break down your food in real time. They are incredibly effective little bio machines eating everything, but too many of them can create quite a competition for your worm, and it can also change the acidity of the soil to where the worms will not be super happy to hang out with them. I noticed when I had too many soldier flies, my worms would actually stay in the lower sections of the bin because they didn't want to deal with all of those guys. So I actually ended up having to slowly begin removing a lot of the larvae, and I also had to increase the amount of brown matter I was putting in, and over time, the flies lost interest.
Yeah, and I think that's like what you're speaking to, Kel, is a really great point, right? You get to learn based on who is arriving, what the soil, what is happening in your worm bin. So everything has a story and a reason behind it, and you can be like little detectives trying to figure out why what is happening. Mine, because I have an inside bin, I tend to not get the black soldier flies. Mine kind of go more into like your fruit flies and your household items. I do have a bin that I use soil, a mixture of cocoa coir and some soil from the forest. I mixed that together to create a different type of bin because I was curious to see what that would look like rather than purchasing worm bedding from, say, like Uncle Jim's worm farm. So I do have some centipedes in there. I had an ant or two who have now migrated out of the bin. None of these have become a problem, but because I do live in a house, right, which I do have fruit, so I'll get fruit flies. I find that covering up the food that I do put in there about 2 inches deep, and then I have just a burlap sack, and on one of my other bins I have a layer of leaves. Protecting the soil and covering that up really prevents a lot of them from entering in. Yeah, anything else, Cal, that you want to mention to folks?
No, I think this slide, the most important thing is the title, right? You're just going to find a lot of weird things in your bin, but you know, it's kind of equivalent to reaching down and scooping up a handful of dirt just in your front yard. You're probably going to find quite a few different friends in there, and they're all kind of working together towards the same goal. So it's about finding that manageable cycle to make sure that everyone's happy.
All right, so now we're moving on to harvesting and using these worm castings, and this is really what you're going for, right? You're using your worms to create these beautiful, beautiful usable compost castings, and there's 2 ways you can do it. I tend to stick to the direct application of the worm castings, which takes about 3 to 6 months to produce, depending on the system that you have going. This time will vary, and you will see they will be like this really beautiful dark kind of crumbly texture. You can, as you can, this slide basically says you can remove worms from it if you want to. You don't have to. If you have a huge amount of compost castings, you can freeze it. I suggest giving it away to people and sharing the love. And you can use these castings anywhere you'd like. You can use them in your home pots. You can put them outside in your garden. The other type of application is a compost tea, where you collect you can see you collect the castings, you put it into a bag, and you essentially make tea from it. This is used mainly for a foliar application. You can use it on the soil as well. It doesn't have as much of a lasting life in terms of giving nutrients for a longer amount of time. Kel, what do you use? You also do direct application, is that correct?
Yeah, I do, and I also keep the worms in.
Yeah.
You know, that's just how it works very well for my garden. Sometimes if I have produce fall off in my garden, you know, I know there are worms in my bin or in my raised bed, so I'll just kind of push the produce under there and kind of do some lazy composting in my beds to continue the worm cycle.
It's smart composting, right? It didn't, yeah.
Yeah.
I appreciate. Cool. So this wraps us up. I know it was a really quick overview of both of these topics, which you can go discussing on for days and days at a time. And it's really a lifelong of learning and being with compost. I don't know, just to kind of to really learn the system. Appreciation, I feel, comes really quickly, and it really gives you a view into a world that perhaps you haven't noticed before, kind of a system working together, all the organisms, that we don't necessarily see on a daily basis. It's a passion of mine, and I think Kelly's as well. So we hope that we ignited something in you to kind of check either one of these out if you already haven't.
Yeah.
Kel, do you want to add anything to these lovely folks? Say something to them, closing thoughts?
Well, Jess, you said everything so beautifully and eloquently, so I don't know if I can
Got
really,
you.
I don't know if I can top it. But you know, consider getting some worms and you know, seeing the cool stuff that they do. Not only is it just a great way to reduce your carbon footprint, your greenhouse emissions, but it's also kind of a learning experience where you get to learn about these organisms that do quite a bit of work under our feet, but we don't always have the privilege of seeing all the time.
Yeah.
So it's a great way to learn a little bit more about how the earth works.
A deeper respect, I think, definitely comes. And it also is amazing when if somebody asks you, oh, how many pets do you have? And you're like, oh, I have 4,000. And it's just like, what? Yeah, so you can have, just kind of the fun things that come with worms and the sharing of them was also beautiful. I enjoy it anyway.
Yeah, me too.
All right, thank you everyone for
Thank
being
you.
here with us.
Thank you. Thank you. Thank you. All right. And I want to apologize. I accidentally hopped over Sarah Bay Nawa, who was to be directly after Ben Frinton. So we're going to switch over to Sarah at this point. And Sarah, are you ready?
Yeah. Hi, everybody. No problem, Noel. I'm going to share my screen here. And I think you all can see that. So I'm going to be talking today about soil health and soil management. It's a really big topic, so I will do my best to not make it boring and to try to get through everything that I am excited to share. I work for Pasa Sustainable Agriculture. If you're not familiar with this organization, we're Pennsylvania based, over 30 years old now, a group of farmers and change makers cultivating environmentally sound, economically viable, and community focused farms and food systems. And we offer a lot of different programming and opportunities for all types of farmers, all scales, all sizes, and my job at Pasa is to coordinate our some ongoing research projects that we have with farmers throughout the state and actually region of the country at this point. One of them is a soil health benchmark study. I'm not really going to be talking about it too much today, but I do want to share that we put out a public report last year. So if you really want to nerd out on soil health on kind of a farm scale, you can download this report for free on our website. I also want to mention that we've got a lot of webinars and print resources available online about all sorts of topics, soil health, etc. And so I'd encourage you to check that out and just check out our organization in general. So real quick before I dive into soil health, a little bit about my background. Before I started working for Pasa, I spent going on 10 years vegetable farming in South Central Pennsylvania. I'm tuning in today from Cumberland County in Newville, but I farmed in Southern Huntingdon County and for many years. And I also was in Chambersburg. I was the manager at the Fulton Farm at Wilson College for about 4 seasons. And so, yeah, this is one reason why I could not say no to speaking to you today, because I love the community of Chambersburg. And so now my scale of growing has been reduced to a garden size, but I have found that, you know, when I learned about soil health on a farming, you know, in a farming system, but there's so many ways that you can apply that scale to gardening and vice versa. So that's kind of how I'll be, like, my approach for this talk today. And I also just want to encourage you to, yeah, always be learning from lots of different places and sources and scales. There's always something to learn. I put this picture here of a dead and dying cucumber plant, diseased, from my garden, just to also remind us that farming and gardening, it is a lifelong relationship and learning process. And I doubt I will ever perfect it, but that doesn't mean that we're not successful and it's not important, and we're not doing some good throughout it all. So yeah, always something to learn, and I hope that I can teach you something today. So I'm going to be doing like a really broad overview of soil health. It is a massive topic, but I hope that maybe there's going to be something today that you are curious about and that you can, after this, kind of dive in deeper and learn a little bit more about it. I'm going to try to get through all of this and we'll see how I do. So soil health, just to dive right in, this is a term that is really coming up to the forefront of conversation with agriculture, especially with the changing climate and weather patterns changing. And at its simplest, it is the capacity of soil to function as a living ecosystem that sustains plants and animals. Often when we think of soil, we think of it providing nutrients for the plants that we want to grow, but it's just a lot more than that nutrient or chemical aspect. There's biological components. Think of the microbial population, organic matter that's part of the soil, and there's a lot of physical components that are really important to make sure all of this functions. And so all 3 of these combined are vital to ensuring that you have a really healthy soil. So to kind of dive into this a little bit more, we need to understand some of the soil processes that are involved in having an optimally functioning soil. So I'm going to talk about some of those right now and kind of, I'll click through this a little bit. All right, so the first thing to focus on is kind of the physical components of soil, the structure. And you can think of that as kind of the house where everything lives. You know, this is where the soil life and the roots roam. And so it's really important that that they have a sturdy and stable structure to thrive in. So what this looks like for soil is we need the soil, the ability to capture water. We need the ability to hold water. You know, roots and soil life need both of those things, just like us. we need the ability for soil to absorb oxygen. Again, for roots and soil life, they need oxygen just like us. And so what that means is that we need lots of different pores and pore sizes. So you can see this picture in the top, there's macro pores that allow water to infiltrate, to allow oxygen to infiltrate, and micropores that kind of can also help to store some of these things and provide habitat for different little critters that exist in the soil. And at a bigger scale, you can see in the bottom picture there, that is what a soil looks like, that has great structure or great tilth, we think of soil aggregates as all the clumps of soil joining together. So you can see in that picture, it looks a little blurry actually, but you can still see those giant clumps of soil that are being stuck together. And so that's providing a lot of great pore space for these essential things that we know need to be captured into the soil. And you can see that there's a lot of great roots growing through the soil. And this is all important. We need soil to not be compacted to maximize that root growth and organism movement. And so structure is really, really important in terms of having a really great functioning soil. Just to kind of now dive into some of the biological components of soil. Oftentimes we think of organic matter first. This is just as a definition, so we're all on the same page. It's really all carbon containing material that is or was derived from living organisms, including plants and soil organisms. So you can think of your crops growing in your garden, the roots that are diving into the soil as organic matter. You can think of residue on the surface as, that's organic matter, things that are decomposing, and then things that are becoming more stable in the soil due to other biological activity. The humus, the humus. Oh, it's so easy to just say hummus. But anyway, these are all parts of organic matter. So living, dead, and stable make up this. And, organic matter also is really important in terms of supplying nutrients within soil. And so when we look at organic matter in the bigger context of soil biology, the soil food web, you can see that it is a really important piece. So this graphic here of the food web, you see organic matter as part of it. You see then next the microbial population all the way up to arthropods and birds and mammals. This all makes up the soil food web and thus the biological components of soil. We know that the microbial populations there, you can kind of see the bacteria and the fungi are the next level of the food web after organic matter. They are really essential in decomposing this organic matter and thus liberating those nutrients from that source for the plants. They are a essential chain link in this whole process. And you can also think about, all the other types of, organic matter, the roots as well. They help maintain the soil structure. They help maintain those stable aggregates, provide lots of pore space for water and air to move through. You can think of the biological properties in terms of disease and pest suppression as well. The microbial populations, that bacteria, the fungi, all the way up through those, ground beetles, they all help provide really important disease and pest suppression within the soil and on the soil. There's, a whole system of microbial communities that exist on the leaves of plants as well. And then when we're thinking about how important the soil food web is, this all requires food in order to thrive. So there's, all these critters, microbes are eating each other as a food source, as you can see from this graphic, but a really also important source of food for some of these communities is root exudates. So that's what this picture is of that kind of teardrop. That's actually a root exudate. And you can basically think of it as like a liquid substance coming out of the root as a direct process of photosynthesis. And there's certain parts of the microbial community that need that to become activated and to survive and to just flourish and help then to provide, they use that as a food source to get the energy to then provide nutrients to the plants. And so it's a whole complicated process, and we could spend a massive amount of time going through this, but just really important to remember that all of this is very important in nutrient cycling, and also, like I said, maintaining really good soil structure as well. So to just further emphasize how complex this is a graphic that I will not go into detail on, but it just lists different types of soil organisms and kind of their categories and major functions. And you can see how complex it is, how many different services they provide. When you read this, you can think, oh, well, all of these are so important. And yes, they are. And there's so many different crossovers and different types of soil organisms performing similar functions in different ways. And it's really important to nurture the biological populations and the soil food web. 1 teaspoon of good garden soil can have, and we're only talking about bacteria, there's all these other creatures could have a billion bacteria and 20 to 30,000 species. So we're talking about a really big ecosystem here. And then that next, component of soil health is thinking about the chemical and the nutrients that are exist within the soil. And so, I just said that the soil biology is really important part of nutrient cycling. And nutrients are important for proper plant health. Proper levels are important. And so just sharing this slide, this is the aspect of soil health that we know the most about, because this is what we focused on for a long time. So there's, it's a good idea to know where your baseline is in your soil in terms of the nutrients that you have. And you can get soil testing done. There's so many labs all around. Penn State is one of them. So you can test for all the essential nutrients. You can test for organic matter. And, I'll say that it's also important to test the source of your nutrients if you're using something like compost, so you know how much you're applying to your soil. One complicating factor that kind of can be head scratching sometimes is that when you're getting a soil test back, high nutrient content does not necessarily mean that plants have the ability to access all those nutrients. And so the more we can think about soil health in that holistic way, the more ability that the soil health will be able to, all the parts of soil health will be able to release the nutrients to your plants. And, soil biology is part of that. And I also just want to say that the over application of nutrients, in any form, whether, a concentrated fertilizer or composting source, it can have negative consequences on plant and soil health and for years to come if it's really extreme. So that's just important to keep in mind. So we're going to be kind of moving on to so that's kind of the what is soil health. Now we're going to be moving on to how can you create a soil health, keeping those optimal, keeping those components in mind and how they optimally function. So one way to think about this is looking at some core soil health planning principles. This is coming from the Natural Resource and Conservation Service. They have 4 key soil health principles: minimizing disturbance, maximizing biodiversity, maximizing soil cover, and maximizing living roots. And these are ways of thinking that can be applied, on the farm scale for sure, and also on the garden scale. But it's also important to keep in mind that these aren't new, these have always existed. And when we think of perennial systems, those 4 soil health principles exist in perennial systems already. So often when I'm thinking of an annual agricultural system, and gardening can be included in that. I hark back to perennial systems. I think of grasslands and think of forests, and how can we mimic some of those into what we do on the garden scale. So diving into each of these principles a little bit. Continuous living roots. So we know that, when we're planting our vegetable crops, our flowers, those are providing living roots, but we usually don't grow those things all year round. Or on every inch of our garden space, whether it be a raised bed or you're just growing in soil. So one really great way to just increase continuous living roots, which will help soil structure, soil biology, is to grow something called a cover crop. And if you're not familiar with this term, it is a crop that grows when or where your cash crop is not growing. So thinking of your cash crop as your vegetable crop in a garden situation. And these can be a whole bunch of different categories of crops. It can be grasses and grain. It can be like rye and oats. It can be things like clover, which are legumes and also provide, added benefits of adding nitrogen to the soil. It can be other crops like buckwheat, which is a really good cover crop to plant in the summer, and the flowers that it produces are really great to attract beneficial pollinators. So lots of different ways that cover crops can benefit you, in addition to having those living roots. Cover cropping can be really simple or it can be really complex, and I don't have time to dive into it. There's cover crops that you can plant in the fall that can last all winter long, which is awesome for providing continuous living roots. There's some that you can plant in the summer that will are sensitive to cold weather, that will die over the winter, but that also is, just really beneficial as well. And, when you're thinking about cover cropping, you can think about, in the where am I not planting vegetables and where could I be cover cropping? So think about cover cropping in your aisleways, maybe if you're growing in the soil, or even you could cover crop in between your raised beds. Just think of what can I do to have living roots in every part of my system. And so lots of great crops with lots of different benefits. And so that's all I have time to say about that, but I would encourage you to dive into that more. And so the next principle we can think of, is minimizing disturbance. So when we think of those perennial systems, the soil really isn't disturbed that much. It would be disturbed by humans or maybe, catastrophic weather events. And so tilling is has been a part of agriculture for a long time, and recklessly tilling can cause really negative impacts on soil biology and soil structure. So this, definitely exists on farm scales, but even on a garden scale, using a garden rototiller, it can be really harmful in certain ways. Tilling can decrease microbial populations. It can destroy those really awesome aggregates that were seen in the picture that I showed earlier. On this graphic, you can see here a no-till system versus a tilled system, you can just envision all the great soil structure and soil biology on the left side that doesn't exist there on the right side. So tilling, you know, it's kind of, sometimes it can be necessary, but there are definitely ways, like this says, to minimize it. And then when we're thinking of tillage on a bigger scale, you know, a farm scale, it can really, it has the potential to cause massive amounts of erosion, like Ben was talking about in the pictures of those deep channels in the ground, or also, you know, the dust bowl. So that is occurring in the Midwest. So what can we do to, you know, minimize these effects? Whoops, let's see. All right, so just less tillage, you know, maybe there's different way. You don't have to till your garden as much, use your little garden rototiller as frequently. You can use different tillage tools. There's some tillage tools that are more gentle on the soil. This is a picture here in the bottom of a broad fork, and that really helps break up the soil, but it keeps those soil aggregates intact. You know, there's things like a bed preparation rake, you know, that I can kind of see in my mind as a substitute for tilling the top of the soil when you want to create a really nice seed bed for your crops. You can think of maybe ways to just not till at all, and to try something like tarping, which can kill weeds and break down crop residue. You know, one reason why we till is to control weeds. So this is a easy way that you could substitute that on a garden scale. You can use black plastic. The black plastic kind of heats up that soil underneath, and so it kills the weeds, can kill weed seeds. And clear plastic can also be used. So there's a whole wealth of information about tarping on the web if you're curious about that. Strip tillage is another thing. So this is just the process of only tilling where you want to plant, you know, instead of tilling up your whole garden. Just till up the vegetable beds, the flower beds, and leave the aisleways intact. And then maybe you can have that space to grow some continuous living roots. The next principle here is maximizing soil coverage. And, you know, this kind of crosses over a little bit with growing continuous living roots. This is important. You know, soil naturally just doesn't want to be bare. It needs protection. I was thinking that having the soil covered is like having the roof on that structure, you know, to protect it from extreme elements, including heat and just extreme weather events. And when we think of weeds, you know, one reason weeds grow in bare soil is because the soil is using them as protection. So how can we maximize soil coverage? Well, we can use cover cropping. We can use cover cropping while we're growing our vegetables or other crops in our garden. We can, you know, interseed or undersow certain cover crops like clover. You'll see that picture on the top right there. That is some broccoli that has clover undersowed underneath it. And that's really just maximizing covering every single portion of bare ground. And that's a great example of how to do this. You can leave residue on your soil. You can do a lot of mulching. You can mulch over the winter if you're not going to plant cover crops, or you can, you know, mulch around your crops that you're growing during the season. And you can mulch your aisleways too. So these are all different ways that you can really maximize this process. And maximizing soil coverage is also one form of weed control. So, you know, if you're covering up the soil, light isn't able to penetrate as easily, and so those weed seeds won't necessarily germinate. And then the last principle here is maximizing biodiversity and in all ways. And what I usually think of this is, we want to maximize the biodiversity on top of the soil to help the biodiversity underneath the soil. So this can be, if you're doing cover cropping, just planting a whole cover crop mixture of a lot of different types of cover crops. When you're thinking of planting your annual vegetables and flowers, you can just think of intermingling them, growing your annual herbs with flowers, next to your vegetables. They all will just benefit the biodiversity of below the ground and above the ground in so many different ways. I haven't talked much about pollinators, but having biodiversity surely encourages native pollinators and beneficial insects to come into your space as well. So just when, when we're thinking about this, we just want to be, again, getting back to a perennial system like the forest. The forest does all of this in itself. And how can we take those practices and encourage them in our garden to maximize its potential and to help our soil perform in all those optimal ways that I talked about. So I'm not sure how much more time I have, Noel.
We're at 10:50 right now. If we can wrap up a little bit, because we went about 5 minutes over on the last one, just to sort of stay on track.
Sure. Yeah. So I will have to click through some of these slides here. One thing that I would like to mention is one particular assessment tool is also through the NRCS, and it's called a soil health card. It is a great way to do some simple quantitative and qualitative measurements on your soil, be your yard, your garden, wherever. It can talk about, go over things like surface coverage, soil structure, organic matter. It's a great way to see where you are currently, and then if you want to apply some of these soil health principles, you can check in a year or so or a season or so and see where things stand. Some of these things take a while to change. It can be a slow process, but some of them you'll be surprised at how instantly your soil responds to them. So I think that's it for me. I do want to share that some of these resources, I could just maybe put them in the chat, but these are ones that I go back to and utilize, and it's a good place to start. So you could Google any of these and dive into soil health a little deeper if you're interested. And that's it. So thanks a lot. Happy to be here with you today and look forward to the Q&A time.
Excellent. Thank you, Sarah. And as Sarah alluded to, again, if you have questions, just please be jotting them down, and we'll address the questions during the Q&A panel. So next up, we have Integrative Pest Management by Annette MaCoy with Franklin County Master Gardeners.
Okay, good morning, everyone. Let me get my screen share. Yeah, I need to. Right. Just sorry, I need to get to my start my screen. There we go. All right, can you see my screen, everyone?
Yes, it looks great.
All right, thank you. I'm going to go ahead. So good morning, everyone. I'm going to talk a little bit about integrated pest management. I call it IPM for short, and most people do refer to it as IPM. So briefly, I'm going to go over the principles of IPM, some key strategies that you can use in the vegetable garden that incorporate those principles. And if I have time, quickly go over some commonly encountered vegetable garden pests and a few of your common beneficial arthropods. So why do I start with a spider on my first screen? Well, because if you learn nothing else this morning, I'd like you to take home the message that spiders and other beneficial insects are some of your best allies in the battle against garden pests. So look at that cute little face. How can you not like it? I know there's an ick factor associated with a lot of these beneficial insects. So it's kind of a matter of attitude adjustment to overcome that. I happen to think jumping spiders are quite cute. So pest control in the garden. First of all, I've been working with home gardeners for many, many years, and unfortunately many gardeners still have a spray first, ask questions later mentality when faced with insects in the garden. And what really does pest control mean to you? Is this something you have to make a decision about? Does it mean eradication or extermination? For many people, when they see an insect, that's what they think of. But when we talk about pest control, even organic pest control, most people, as I said, many people first think of a bottle of something. Even if that something is what's called an organic pesticide, it should really be the last thing you think of when faced with the pest problem. And we need to rethink how we approach pest management, because I think in general, and this is a good thing, gardeners are becoming very aware that our gardens are part of larger ecosystems, part of the surrounding ecological community. Gardens are not separated or isolated from nature. And anyone who has had deer munching their way through their garden knows that. But seriously, the things we do in our gardens have an impact, for good or bad, that extends beyond the boundaries of our gardens. So when we think of pest control, we need to think on a larger, more ecologically sustainable scale to manage, not necessarily eradicate or exterminate, the pests we find in our gardens. And this approach is what we call integrated pest management. Pesticides, those chemicals we've used for years and years as our first line of defense, are really not sustainable in the long term if you're not using other methods of pest management, because pests develop resistance to chemicals. Chemicals therefore become less effective at control, or they may have unexpected consequences and side effects on other organisms in the environment. So those things you need to consider very carefully before you reach for a bottle of any kind of pesticide. So as I said, many insects are developing resistance to our commonly used pesticides, insecticides, the same with weeds. Going a little further afield, think about antibiotic resistance that's developing among bacteria. And so those are all things that we need to consider carefully. And just to leave you with this note, no fly has ever developed resistance to a fly swatter. So when you think about other methods of control, there are many things that you can use where you won't have those long-term consequences of chemicals. So what are the steps in IPM? Again, I'm not going to go into this in great detail, just real briefly. These are the traditional steps in an integrated pest management system. First of all, identify the pest and understand its life cycle. And make sure when you're looking at something going on in your garden that the damage you are seeing is really being caused by the insect or the organism that you notice. This is not always the case. So in terms of insect identification, that can be hard. The extension office, the master gardeners who operate the garden hotline, we can help you with identifying pests, insects you may find in your garden. If we can't do it, there are resources at the university level that can help us make that accurate identification. monitoring the pests. How bad is the damage? Will it kill or seriously damage the plant? Many instances, no, it won't. So there may be no need to actually do extensive control or management of that pest. So that comes into play when you have to decide on your threshold level and your goal for management. So that threshold level means basically how much damage can you tolerate? For some people, seeing one insect is like, help me, get rid of it. For others, you have to just realize that you're going to have insects in your garden no matter what you do. Can you accept some of those insects? Can you accept and tolerate some of the damage that they may cause to plants in your garden? Obviously, for farmers who rely on the crops they're growing to have a livelihood, to make money, they may have a lower threshold level for the amount of tolerable damage than you as a home gardener might be able to accept. And then what is your goal for trying to manage these pests? I would encourage you to look at ways to prevent and suppress rather than look at total eradication as the goal for an IPM approach. Total eradication very rarely works anyway. And then you use the IPM triangle, which I'll show you, to decide on and implement a variety of control strategies. So integrated, when we talk about that, we're not talking about just using one method. We're talking about developing a whole framework of strategies that you can use to manage the pest to a level that's tolerable in your garden. And then the last step would be, after you've done that, evaluate how well those strategies have worked and if you need to modify or change them for future use. So here is just a quick look at the IPM triangle, they call it. So I kind of look at it as like the old food pyramid, if you remember the old food pyramid. So all the stuff we traditionally have used, the pesticides, and that's comparable to the sugars and sweets in the food pyramid, are at the very top, the smallest part of the triangle. And so that should be the thing we use the least. Like they tell us, don't eat too many sugars and sweets. All the other stuff we should be doing first before we reach for a pesticide are further down in the triangle. They are the bigger part of the triangle. So that's comparable to the whole grains, the fruits and the vegetables we should be eating in preference to sweets. So anyway, to look at this, the base or the foundation of the IPM triangle is biological control. And that's basically the use of natural enemies, such as parasites, predators, and naturally occurring pathogens to reduce pest problems in the garden. The middle are lots of other tools that you can put into your IPM toolkit. Things like cultural controls, mechanical and physical controls. These are all approaches that you can use in the home garden. And then there are some others, things like genetics and host plant resistance, which are more scientific approaches that may not be usable by you as a home gardener, but you can benefit from the research that scientists do on some of these techniques, such as developing disease resistance in plants, and then employing those in your garden. And then the very tip is pesticides, chemical options. And again, this is anything that you use that's a registered chemical would be considered in that top, and that should be your last resort. So you'll notice that as you move away from the foundation, the bottom of the IPM triangle, you're going to experience increasing costs and environmental impact and decreasing sustainability and species diversity. And certainly one of the things that many of the presenters have talked about this morning so far are the importance of sustainability and species diversity in our gardens. So a few key strategies to cover with you: scout early, and this is focus more on the vegetable garden than the ornamentals. So scout early, scout often, manage the pests before they get out of hand. So pay attention to what's going on in your garden, practice good sanitation, encourage those beneficial arthropods. And then if you have to get to that very tip of the IPM triangle, use the least toxic pesticide options. If they're needed, you may find that they are not needed. So scout early, scout often. You know, many longtime gardeners will tell you, get out there every day into your garden, even if it's just for 15 minutes. Look at your plants, look for signs of damage. And where are you going to find those? Look the base of plants, underside of leaves, stems. Don't just look at the top. Oftentimes insects and pests will be hidden on the underside, on the stems, at the base. So you need to look at the whole picture, not just the top of the leaves. And then if you see damage, the pattern or the type of damage that you're seeing can clue you in onto what type of insect may be causing it. So different feeding patterns or different feeding methods can cause different types of damage. For instance, beetles and caterpillars have chewing mouth parts, so you'll see pieces of leaves chewed off. Bugs, aphids, scales, spider mites, and thrips have sucking mouth parts. So what you'll see are spots or places where they have sucked plant juices out of the leaves. And then things like slugs and thrips have what are called rasping, scraping mouth parts. And again, you'll see just almost like someone has scraped off part of the leaf. Something has scraped off part of the leaf. So learning more about insects, and again, once you've identified it, understanding how it feeds and what its life cycle are, can help you to determine what may be causing the damage. So chewing could be holes and edges and skeletonizing of leaves. The sucking may lead also to distorted and curled foliage from the plant, from the juices being sucked out of the leaves. And then the rasping and scraping, as I mentioned, can leave little rectangular surface scrapes. And again, early intervention can make all the difference. Getting out there daily, and if you find a few, you can just hand pick them, and that may take care of your problem. So scout early, scout often. And again, learning to identify which are good guys and which are bad guys, that comes with experience, but we can also help you at the extension office. Manage the pests, or at least discourage them. And again, there are a lot of other approaches besides the use of pesticides. Row covers, barriers, collars, and sticky traps can physically keep the insects off of your plants. Physical means, hand picking and water spray. I often recommend these as an easy approach to managing just a small infestation. And mulch and cover crops, as mentioned, can help to build organic matter in the soil and also to suppress certain pests. Crop rotation, confusing the insects. You know, they expect the same crop to be in the same place every year in the vegetable garden. Well, if you mix it up with crop rotation, mix in some herbs, some onions, popcorn, greens, you know, you might confuse the insect that expects your corn plant to be in the same spot every year. So those kind of things, insects are small and have small brains, although they are, you know, smart for what they do. But you can confuse them through some of these methods, crop rotation and other things like row covers. And then tolerance or wait it out can be effective. Sometimes the damage may be for a certain period of time, and then something else, they may be done for the year. So, you know, doing nothing sometimes can be an effective part of IPM strategy. So just real quickly, some cover crops and floating row cover. I don't really have time to go into detail about how to utilize these things. Sarah talked about cover crops. Floating row covers can be very effective in the vegetable garden, and there's a lot of good information on online about how to use them, because for crops that are flowering and need pollination, you're going to have to take them off at certain times. And then practice good sanitation. So check your transplants carefully before you bring something home from the nursery center, the garden center, if you've purchased it, again, look at it carefully. Look at the base of the plants, look at the underside of the leaves to make sure you're not bringing something that is infesting their greenhouse back home with you into your own garden. If you have diseased or rotting plants, parts, get rid of those as soon as possible. Just diseased areas will attract insects or pests that you may not want to have in your garden. Keeping plants up off the ground helps to keep them clean. And that again can minimize the number of pests getting up onto your plants. Controlling weeds up to a point. Sometimes weeds can act as sort of trap crops and barrier crops at the edge of your gardens, but you don't want them in the middle of your garden because again, they will often attract insects that may become pests in your garden. And then cleaning up diseased or decaying plant debris at the end of the season. Many of insects will overwinter in that diseased or decaying plant debris, and then be there ready to start up again as soon as spring arrives. So encouraging beneficial arthropods. So beneficial predators and parasitoids are you're great allies in the vegetable garden. Things like spiders, ground beetles, wasps, green lacewings, lady beetles, and ants. And I know, again, a lot of these have an ick factor that you may not like to see them in your garden, but they really are your friends in the vegetable garden. Planting a diversity of plants and flowers for nectar and pollen. Anything that's good for pollinating insects will also be good for beneficial insects. So including herbs and flowers in your vegetable garden. So mix up your plantings, as I've talked about, mixing it up to confuse insects as to where a particular crop is, but also mixing different types of herbs and flowers, again, will, not presenting the pest of a particular plant with a whole monoculture of that particular crop makes it a little bit harder for them to move around and find what it is that they want to feed on. So leave some garden areas less managed to provide food and shelter over the winter for insects. And creating sanctuaries, that is places where you kind of leave it alone, you're not doing anything, again, will be a good place to attract and provide habitat and shelter for beneficial insects and arthropods. And you do have to remember that you're going to have to allow time. You have to allow time for these beneficial insects to do their work. There's no Twitter, there's no Instagram in the garden. Things don't happen instantaneously. It may take several weeks, so patience is a virtue. Nature works, but you have to give it time to work. And then if all else fails, you may need to spot treat with the least toxic options that are available. And again, broad spectrum insecticides generally don't encourage those in the vegetable garden because you've got a variety of different crops. So you may need to look for those particular least toxic options that will treat or attack or control or manage just the pests that you want to control without harming or those beneficial insects and arthropods that you do want to preserve. So a few common garden pests, aphids. These are pretty very common. There's hundreds of different species. So to identify them, two things to look for. If you'll look at the end of these, you'll notice that they're called cornicles, but they actually look like little tailpipes on the end of the aphid. And then the other thing you may frequently see are the cast skins. So as they're molting, they leave their cast skins behind. And sometimes you may see only the cast skins and you don't actually see the aphids because they may have moved on or something may have done some control for you already. Hundreds of different species of aphids ranging in size, shade, different colors. Some of them will have wings, some of them without. So this is just an example of a red aphid on some kind of an ornamental, I forget. They tend to like cool season vegetables such as peas, broccoli, and leafy crops, but you can find them on just about every garden crop, including tomatoes and corns. And if you have aphids, look at this as like the plains of Africa, where you will have, your your zebras and your antelopes and things that are going to attract your predators. Well, having aphids are like the prey for the predators. So if you have them, you're going to attract beneficial insects into your garden, and those beneficial insects may do most of your control for you. So the curled, distorted foliage, they also often will produce honeydew, which is a sticky, sugary substance that they eject from their bodies as they're trying to absorb nutrient from the sap that they're sucking. So some management strategies for aphids include tolerating the damage. Usually if you allow the predators to come in, the beneficial insects, they'll take care of them for you. A stream of water is very effective at controlling aphids. It will wash them off the plants, and they are very small, so they often can't find their way back onto the plant. And there are some a few pesticide options, some least toxic options that you can use. Colorado potato beetle, the reason I include this one is because most all of our conventional pesticides will no longer control the Colorado potato beetle. So frequent long time, people used to use 7, which is a common long-term broad spectrum insecticide. They developed resistance to it. So you can spray 7 all you want. It will have no effect on Colorado potato beetles. They overwinter as adults, so they emerge in the spring just when new potato plants are emerging. So a layer of straw around the base of the plants in your potato patch will help to keep them from being able to lay their eggs, emerge from the soil and lay their eggs. These are the potato beetle larvae. So you'll find all stages of beetles, both adults, larvae at different stages of development. They're slow moving, they're easy to see, so they're easy to hand pick. If you get out there frequently, as mentioned, scout early, scout often, they're pretty easy to just brush off into a bucket of soapy water. And hey, if you have kids or grandkids, here's a great opportunity to get them out into the garden, have them control your Colorado potato beetles with hand picking for you. So there are, as I mentioned, there are multiple generations per year. You may see adults as well as larvae. And there are a few pesticides options that will still work, something like neem oil, and there is a BT, a Bacillus thuringiensis variety that will work on early instars, but really handpicking, because of their behavior, is one of the best ways to manage them. Flea beetles, these are fairly a lot of different species of flea beetles. They jump. They're very small, and they jump because they have that enlarged femur on the hind leg there that allows them to jump like fleas do. But they're small, as I said, about the size of a pinhead. And this is the kind of damage, they call it shot hole damage, because they feed on a lot of little spots because they're so small, and they form tiny little holes in the leaf. And although this damage looks really bad, it usually does not significantly reduce yield, so you might be able to tolerate it. So this is a good example of an insect where you might not need to really do anything, as long as it's not affecting or impacting your crop production to a great extent. So
Annette?
floating, yes.
Hi, it's Noel. Just wanted to let you know we're at 11:17.
Yes.
And so maybe by 11:20, if we could wrap up.
Okay.
Thanks.
All right. So gonna just floorline plant bug again is one of those that you can tolerate by just letting it go. The damage looks terrible. They appear in May, but they only have 1 generation per year, so they're usually gone by June, and the plant will grow out from the damage. So although this looks terrible, it looks like it may be a disease or something, I usually just let it go, and knowing that they'll be gone and the plant will outgrow the damage. So that again is another approach, a wait and see approach for managing using IPM in the garden. And then 2-spotted spider mites, very, very small. This picture was taken with a microscope, so you know how small they are. This shows you a little of the damage that they can, that stippling bronzing type of damage that they can cause as they suck out plant juices. They like hot, dry weather. They don't like moist conditions. So again, this is where using just like a spray or a stream of water to wash off the plants can be very effective. And encouraging predatory mites and other beneficial insects to manage them. So just to show you a real quick few pictures of some common beneficials, and I know the ick factor often comes into play here. But if you can overlook that, appreciate them for what they do, you can learn to tolerate and enjoy having them in your garden. This is an assassin bug. This is a generalist predator. And this is, you can see that stylum that they have that they use for piercing and sucking. It's quite gruesome, but that's what they do. This is early instars. So the early instars look completely different than the adult assassin bug. Of course, our honeybees, we want to encourage those for the pollination services. Tobacco hornworm, if you see this on your tomato plants with those cocoons, those white things, leave that tomato or tobacco hornworm alone, because those cocoons will hatch out. What's happening is the larvae of this particular braconid wasp is actually inside the tobacco hornworm, eating it from the inside out, and then they produce these cocoons that will then open up, and out from that will emerge another adult, a braconid wasp, who can go and find another tomato hornworm to infect. That's their ovipositor that they use to lay eggs inside the tobacco hornworm. Green lacewing adults, very cute and very pretty. So if you see them, you'll leave them alone, because you want to have the larvae. This is what they're often called aphid lions. So not very attractive looking, but if you want to have, they do eat a lot of insects, aphids, mites, insect eggs, strips, mealybugs, scales, etc. So you have to have the larval stage if you want to have the adult stage. So you have to learn to leave the larvae alone to have the adults. Ground beetles, mentioned those in an earlier presentation, very beneficial for controlling many soil dwelling pests, including larvae and eggs. Lady beetles, we all go, they're cute, but you have to leave the larvae there. And they look like little alligators. You have to leave them alone if you want to have the adults. Both stages will do a lot of pest control for you. Praying mantids are generalist predators. They will attack some good, some bad, but overall they may provide some benefit in your garden. And there's a crab spider catching a hoverfly in the garden. So again, spiders are great. They are generalist predators. So they will sometimes catch good guys as well as bad guys, but overall they can provide a great level of insect control in the garden. That's the yellow garden spider. And there's a jumping spider, another one. Remember, he's happy to help. He says, I'm waiting to help you. I'm wanting to help you. I'm willing to help you. So you just have to let them. And to let those beneficials survive and thrive in your gardens, creating sanctuaries, perennial flowers where they can shelter and provide and have habitat from year to year. Anything that's good for your pollinators is going to be good for your beneficials. So just real quickly to recap, so integrated pest management is ecologically sustainable. It protects species diversity. It encourages beneficial arthropods, and it encourages minimal use of pesticides. So it's really the best approach for thriving landscapes and thriving communities. And I will finish off with that.
Excellent. Thank you so much, Annette.
You're welcome.
All right. And again, save your questions until the Q&A, which will follow our next presenter. Our next presenter is Julie Emig, and she'll be presenting small space foodscaping. Julie, are you ready?
Just about. I need to pull up my screen or my presentation.
All right.
Okay, I think I'm ready. Can everybody hear me and see my screen?
Yes, it's beautiful.
Okay. So I'm Julie Emig. I am a gardener. I just retired from teaching music in the Chambersburg area school district and also Cumberland Valley School of Music last year, and have been enjoying being a part of the Healthy Franklin County Community Garden Work Group since then. So I'll just go ahead and get started. Small space foodscaping. It's a play on the word landscaping. Instead of landscaping, foodscape is an outdoor space that combines both edible and ornamental plants. And you can be a beginner or you can be a really experienced gardener. Either way, it's really fun, a fun way to grow food and to just garden in general. This is an actual picture of my backyard in a springtime in the past. Here are some ideas of other people that they have done. This garden here on the left has some mesh here that's kind of keeping it under control, and there's some looks like marigolds, and here's some herbs, and then there's a big squash, and I'm not sure what's back there, but that's all kinds of stuff planted together. This is a more formal garden with some brassica family vegetables growing in there. And this one is a block wall that I don't know if it was put in just to grow the food or if it was already there and they grew food in it, but there's a tomato plant and some other things growing on that too. So all three spaces are really different. And then you can also grow things in containers. This is a very interesting, instead of landscaping along the side of the house, everything is in containers. So there's all kinds of food and flowers growing there. This one looks more like some kind of an urban setting with all the these metal containers. And I'm not exactly sure what this stuff is around the bottom, but there's all kinds of food growing in containers there in metal containers. So this is a shot of my backyard. Several years ago, we had an old oak. It was like a manger type thing. I don't really know, but it was falling apart, and we repurposed it and made a salad table out of it and grew some lettuce in it until it fell apart, and then it ended up in the compost. You do want to make sure that you only put wood in the compost that's not toxic, and that was just old oak, so it was okay. So the vegetables that we've grown over the years are listed here. I'm not going to read through all of them. Hopefully the information, I have a lot of links in this PowerPoint, so hopefully you'll either be able to view the PowerPoint in the future, like access it somewhere, or else I have my email. If you email me, I can put them all in a document. I don't have time to put them in the chat, but I could put them all in the document and email it back to everybody. But this is all the stuff that we've grown. You can't grow everything all at once because in a small space you don't have room. But these are all the different things that we have done over the years. And Malcolm, the volunteer, squash from the compost pile. One year, our patio is in the back of our yard and it's shaded back here. So that's where our patio is. And in the far back is the compost pile. And we had a volunteer squash that grew out of the compost pile, and it was so beautiful. I didn't have the heart to rip it out. And we named it, and its name was Malcolm. And so now every year we have an honorary Malcolm that we allow to grow out of the compost pile. And last year, I mean, it's usually a mystery squash because of cross-pollination, but last year we had a beautiful white pumpkin that came out of it. And then herbs, this is also my back space right outside of my, this is my back porch area right there, but the herbs that we grow every year are basil, chives, dill, lavender, mints, oregano, parsley, rosemary, sage, and thyme, because we use them always in cooking and all kinds of things. And so some of the, this is to the left of the porch. Here's some kale, and then here's oregano and different herbs. Some of the herbs are in the raised bed, some of the herbs are in pots. And as you go back farther, you will see the problems, which I'll talk about in a few slides. So going from grass to garden to help your space become a thriving habitat. Instead of just having grass, which doesn't do anything for the habitat, you can convert your space into a garden. Now, I know that some people say, well, where are my kids going to play and things like that. When our kids were little, we did have garden space. We live in town. We are really close to a playground too. And we walk our dog instead of letting our dog out to the yard. But anyways, you have to make a decision for yourself whether or not you are able to, how much grass you want to keep. So here are, this is an example of a planned community in Illinois called Prairie Crossing, where the people actually don't have grass. They are growing native Illinois plants in their yards. What is part of the contract or whatever it is to have property in this area.
Doing the hard stair walking here. So
Someone needs to mute their mute your microphone, please. I'm picking up.
oh, you got it too. Give me that.
Can someone please mute your microphone? Okay, well, I'll keep going. Hopefully they will mute. Here are some articles about grass. Grass lawns are an ecological catastrophe and more sustainable and beautiful alternatives to grass lawns. You can look at those because we don't have time today, but hopefully you'll be able to look at some of these links that I have. So when we transformed our grass to garden, this is what we saw. When we moved in, we saw slugs and pill bugs, and that was about it, and ants. When we started gardening, all of a sudden redworms appeared in the compost. I never bought redworms or anything. They just showed up. We had earthworms. I had salamanders. One day I was weeding and I saw this little tiny black toad looking at me. We've had butterflies, moths, and insects, hummingbirds, cardinal family, and lots of other birds, bees and beneficial pollinators, praying mantis, and lots of garden spiders have decided to. So I was listening to Annette talking about garden spiders, and yes, they take care of a lot of the bugs that are flying around. So this past year, I introduced a mason bee house. Mason bees are solitary bees. They're not like honeybees, so you don't get honey, but it's not like the where there's a queen bee, and every female mason bee is fertile and will lay eggs. And so this little bee house has 1, 2, 3, 4 places. I went out there a few weeks ago and took this picture where they have nested. So hopefully we'll have some baby bees that come out. And here's a link about mason bees and beehives. You have to be careful what kind you get. If you look at this, you can see that this all comes apart in pieces. You have to clean them apparently because they can harbor disease if they just keep going in there year after year. So you do need to clean it out occasionally so that it doesn't develop whatever it is that will harm the bees. Now this is a picture of my backyard when my kids were little, and this is a swing set. Here's the grass trying to grow. Not much is growing back here. And this is what it looked like after we turned it into raised beds. And over here you can see the swing set, which we didn't know what to do about the swing set. The kids are gone. What do we do with it? It was cemented into the ground. Do we hack it off? We decided to keep it and turn it into a space to grow vertically. So we've had various things growing in there, from tomato plants to pole beans and cucumbers, things that we train around the lattice. So this is a different angle. The picture here is from the other side. And then here, this is from standing on the porch. And we made the decision to do raised beds because we have an old house, and there's always the issue when you have an old house with exterior paint with a problem of lead being in your soil from chipping off. So you want to be very careful. That's one thing with foodscaping. I would not put food close to the base of my house because of I'm sure I could get the soil tested, but because of the risk of lead poisoning. So that's something that you have to think about. So foodscaping, if you're going to foodscape, you need to plan. You plan ahead. Where are you going to plant things? These are the things the next few slides are going to address. Where to plant, tools you'll need, sizes, what to put down in the pass, soil, seed sources, plant choices, and water. So where are you going to plant? With foodscaping, one of the tricks is to plant between existing landscaping, but make sure you don't have lead or other toxins in the soil. If you use containers, don't forget you have to water, and you also will have to fertilize your plants in the containers. And in raised beds, what do you use for to make them? You can use wood, you can use cement blocks, you can use bricks, you can use metal. There are all kinds of things that you can use. And there are all kinds of plan ideas on the internet to make your own. You can buy them already made from some of these gardening catalogs that come, but they're super expensive. This article right here is about pressure treated wood. Is it harmful to use in the garden? Is it toxic? We bought one cedar. We made a cedar bed out of cedar wood, and it was expensive. Cedar is naturally resistant to rot, but the rest of all of our beds are pressure treated, and apparently they use copper in pressure treated wood now, and not the arsenic that they used to use years ago. Use what you already have to plant in. I have used yogurt containers that I drill a hole in the bottom, like I stack them all up and drill down through the bottom to transplant my tomato plants in. I've started tomato seedlings in those little plastic Keurig cups they already have a hole in the bottom. I found reusable Keurig cup things that you can refill. So I don't have the plastic waste from them anymore, but that's something you can use. So try to use what you have already. I also reuse pots. Some people say you shouldn't do that. I reuse plastic pots until they break. I scrub them really good in water outside and put them in the sun. And I haven't really had a lot of problem with recurring disease or insects. And also you have to make sure you know if your plant needs sun or shade. And as far as tools are concerned, I use a trowel more than anything because of my raised beds. If I'm going to dig a lot, of course I need a shovel and a rake, but I have found over the years that I really don't need any gadgets. Pruners and a trowel. You can really do a lot of gardening with just basic tools. Okay, the next category or next item was sizes. Make a little map, measure your spaces, make sure that what you're planting is, you read the label and figure out how far apart you can plant the things and don't crowd them. Make sure you have enough space between your garden beds that you can walk between. You can also, you don't have to have raised beds if you're not worried about like we were about the lead. You can plant right in the ground. But my experience has been that everything that I put in the raised beds just thrives. They just love the raised beds. I think it's because the soil is so loose and it soaks up, it keeps the water. If you're going to plant in existing landscaping, and don't plant don't plant a squash by your favorite rhododendron or something that will, you have to plant, you have to make sure that it's not going to choke out what you already have. Okay, and what to put down in the paths. I was listening to Sarah Bay. I just learned about putting a cover crop down in the past, and that is something that I would like to try. Right now I have mulch. Here are some different ideas. This person has a kind of a formal setup with brick. This one is mulched. This one's stone. I did not have good luck with stone because I found that debris got down there, biodegraded, and that grew up with weeds. And then you try to rake, you can't rake the leaves off of it because you get stone too. And I removed all my stone and replaced it with mulch, because when I rake up things with mulch, I can compost mulch that comes up with the in the rake. And also you can just put it right into your compost and have it turn into soil. I've also stopped buying mulch, and I have a shredder that I shred up shrubbery and cuttings and stuff, and it makes just about enough to mulch the back area. This person used walking stones, and there are some weeds coming up there, so you do have to try to find a way to keep the weeds down. And this one here, this is really cool. You could do, thinking about what Sarah was talking about, you could put some like really cool moss in between here, or some maybe creeping thyme or something that could actually grow and fill that space. And then you wouldn't have to worry about weeding it, and it would become part of the ecosystem. Yes.
Hey, it's Noel. I just wanted to let you know we are at 11:40 and we were running a little bit over. So if we could shoot for 10 or 11:50 and then have 10 minutes for Q&A.
That's fine. I'll Zoom. I'll do, I'm too old for speed dating, but I'll do that speed thing that Jessica was talking.
Okay. All right. Just wanted to let you know where we were and to try and figure out our wrap up, since we were running a little bit late. All right.
Okay.
Thank you.
So, potting soil. I'm not going to get into soil because Sarah covered soil and compost was covered, and learned so much, but I did want to share that what I do with potting soil. I make my own potting soil. This is just an estimate. I just kind of mix it up till it feels right, but I use coconut fiber. Don't use peat moss. Try to avoid using peat moss as much as you can. I can't find coconut fiber. I have to order it online. It comes in a big block and I soak it in water. Peat moss is bad because it comes from peat moss is the places in Canada where the peat moss comes from, the bogs, holds carbon. And every time that they go in there and take out the peat moss, it's releasing more carbon, and it's not sustainable. So please try to avoid products that have, it's hard to do, but that have peat moss in them. Coconut is renewable, and you can, it's much more eco-friendly. And then I sift my compost and add perlite. Okay, so another thing that's really near and dear to my heart is seed sources. When you go to the grocery store and buy a seed packet, or you go to the nursery and buy a seed packet, you're probably buying seeds from a corporation that is in the business of seed extinction. Our seed supply has been reduced by 90% since I don't know if I have my dates right, but 1903, just because of our seed supply. It used to be handed down from one person, neighbor to neighbor. Corporations have gotten a hold of seeds and patented them, and intentionally caused extinction. And this is very serious because, especially with global changes, we need seeds that have a lot of biodiversity. We don't need limited seed supply. So there are people around the world. There's a vault in Scandinavia somewhere that's deep in the ground where they're saving seeds. There are people all over the country, all over the world, who are trying to preserve seeds. So this book I read a number of years ago. This is Denise Ray. She also, there's a link down here. She gives a very short lecture at Emory University on why she wrote the book. And she's a seed saver. And this is a book by a woman named Cindy Connor, and she is a permaculture educator. And you can find out a lot about it, that subject here as well. These are good seed sources. I have this one included here, heirloom seeds and poultry. It's Iowa, so it's not really our part of the country. So, I mean, this one is the Northeast, and you want to get seeds that are for your climate. But I included them because they have over 225 different kinds of sweet potatoes. You can order slips from them. If you want sweet potatoes, they have every possible thing that you would want. And also heirloom poultry if you want to go raise those. Plant choices, you have to decide if you want sun or shade, seeds or plants. I'm going to have to go through this because, or pass this because I don't have time. Read your labels, look it up online. This is a source and hopefully you'll be able to access this. The DCNR has extensive information about native plants. And here's a whole bunch of links to the right on what kind of native plants. If you grow native plants in your yard, you'll be supporting your native birds, native insects, and native wildlife. These are some nurseries that have websites where you can actually order things. I know that Larkin Greenhouse has native plants now, and so does Snavely's. So I'm assuming that this is becoming more because of the demand for them that more and more places are offering. Flowers, I'll zoom past that. These are some of the flowers that I've grown in my backyard. Watering, Ben talked about water. The water that we have, even though it seems like in our area we have a lot of water, you know what? It's not our water. It came from somewhere else, probably drought-stricken west. It comes over and waters and rains on us. So we are fortunate in this area, at least right now, to have adequate water. But these are some things that you can do. And whenever I wash my vegetables, I always say, I don't like rinse the water down the drain. I fill a container, I swish them in the water, and then I water my plants with that water. So you can save gallons of water doing that. Mistakes. I've made a lot of mistakes over the years. One of the big ones, which I said I would talk about, but I don't really have time, was planting this wisteria. This is an extremely invasive thing. If I lived near a forest, it would be horrible. They shoot out the seeds like from when the pods, they kind of explode. So it would become awful really quickly, but it is gorgeous and the bees did love it. It has been cut way back since then. The one thing that it did do was lure the cardinals because they like the protection. And these are some of the problems. This is an example right here of what happened one spring when I didn't get out there. This box was filled with these buttercups, which are horrendous to try to get out. This overgrew. It just, you have to really keep after it. And here is all the weeds that grew in the mulch. Also, I have a problem with mosquitoes every summer because of all this place for them. So I need bats. If anybody has any ideas about getting rid of mosquitoes, let me know. Also, don't cut your stuff down. These are the pole beans that grew on my on my swing set last year, and I saw a female cardinal munching on one of the beans. So they will take shelter in the vines, and they will also eat the seeds. So I'll leave you with this. This was in my backyard, checking out the tomato plants.
Excellent. Thank you so much, Julie.
You're welcome. If hopefully I'll be able to get these websites out to everybody.
Right. So what we can do too is for individuals who would like copies of presentations that were made, we'll provide the contact information in our follow-up email, and you can contact that presenter direct and ask for a copy of their respective presentation. So what we'll do now is I will work on getting all of our presenters up on the screen here. Who am I missing?
Ben?
Ben. My listing is, oh, it keeps moving around. Sorry about that.
And Noel, I'm going to cover for my sister and I, just a heads up.
Okay, sounds good. Okay. So we have Annette, Julie, Jessica, Ben, and Sarah. All right. Well, thank you, everyone. Thank you for attending today. And I hope you have your questions ready to go for those of you that have questions. What we'll do is if you'd like to ask a question, you can either raise your hand virtually or put a question in the chat box, and we can go back and forth, and we'll take turns with the virtual hand waving and questions that are put in the chat box. And I don't see any questions so far.
I believe Sue has one.
Oh, does Sue have one?
Question.
Oh, I see a question from Jan. Where's the one from Sue?
I just saw a hand waving.
Oh,
waving.
gotcha. Okay, we'll start with Jan first. Then we'll go to Sue. All right, so Jan, is moss harmful to the garden? I have a lot. I don't know whether to pull it or leave it. Who can answer that?
Ben.
Yeah, so the question to most questions are, it depends, right? So moss is an absolutely amazing organism. It does not harm particular plants, but it can be a sign that your soil is particularly acidic, which means it's not going to be ideal for certain veggies and things like that. But when I see something like moss growing in my garden, I'm going to try to plant woody plants around it. It's an organism that really helps fungal networks in the soil and keeps your garden moist and grows in nature with woody plants. So always looking to nature for the answer. And that would be my suggestion.
I second.
All right, excellent. Sue, you had your hand up. Are you still on?
Yeah, those container gardens like salad tables and the big pots, is that soil replaced every year? Because I've heard that it doesn't grow very well after the first year, but I don't know. I don't do much.
I can only share what I do, which I don't know if it's right or not, because I'm not an authority, but I will take my pots and I will dump them back into like the compost and stir everything all around and just, replenish it. But I wouldn't throw it like out in the garbage or anything. So where else am I going to put it but back into the, I don't know. What does everybody else think about that?
Yeah. I could add, when you're thinking about a container versus growing in the ground, there's a limited amount of soil and thus nutrients within that container, and it can be used up by what's ever growing, or if it's getting rained on and outside, and water could potentially be leaching out some of the nutrients. So over time you will, like Julie, that's a great suggestion. You'll just need to keep adding more fertility in whatever form if you're going to keep growing in that particular pot, or utilize Julie's suggestion.
I would suggest that you can use it probably for a few years, but that what you have to watch out for in addition to the fertility is the structure, because eventually those potting mixes are generally very high in organic matter, and eventually that breaks down so it compacts, and you'll lose that structure that you need for drainage in a container. So you may be able to use that same potting mix for a couple of years, but at some point you will need to replace it altogether. I know I used to work where people, or hear about people who would just take off the very top layer and replace that, but eventually you're going to have to replace the entire amount of potting, the whole thing, just to maintain that structure in the container.
When I dump out my pots that are sitting outside on the ground, there's always earthworms. They make their way up into the bottom of the pot. But yeah, I mean, I don't use this. I dump it out, mix it up, and then use it over. I don't plant in the same pot, actually, one year to the next.
Okay, let's shift over to chat box again from Madge. My yard is full of the new jumping worms. What should I be concerned about?
Wow, I have yet to see those and I really want to. It's something that you just have to keep an eye on. Do not use them in your, if you're gonna make a worm bin, in your compost. They are part of your ecosystem now. They aren't gonna do, from my knowledge, I have limited experience with them, too much damage, but they are an invasive worm at this moment. There is some internet research that you can do on that, but just don't add them into, like, intentionally to your worm bin or anything like that. I'm sorry if that doesn't answer your question directly. Maybe, Annette, you have some information.
Yeah, they can actually cause extensive damage to the organic matter in the upper part of the soil horizon. So they basically turn your organic matter into like coffee grounds. And I've heard some master gardeners and others say that it's very, very difficult to keep that organic matter in the soil, and they make it difficult to grow good crops just because of the damage they do to the organic matter. So yeah, it's a big problem. They don't have a real solution yet as to how to manage it, except try to keep them out. And that's becoming increasingly difficult because they are spreading. They are easily spread, for instance, through water, through nursery containers that you may purchase. May have the cocoons, which are very small. Once you have the cocoons in, they can, then become part of your garden. So basically, if you're buying, I would recommend, if you're buying nursery plants, to bare root, to wash off all of that external soil before you put them in your garden, just to make sure. And then you need to do something with that washed debris to make sure that it doesn't have any or jumping worms or cocoons in it. It's also possible that mulch can contain the jumping worms, as well as bagged materials, like organic matter or humus or compost. They don't survive on temperatures, supposedly, from the research they've done so far, temperatures over 105 degrees Fahrenheit will kill the worms and the cocoons. And so if you bring in bag materials, I'd recommend, if you can, leave those out in the hot sun for several days, just to make sure that you are, if there are any worms or cocoons, that it's getting hot enough inside that bag to kill what's in there.
And I think too, like, this is where we go back to looking to our landscape. If we're calling in birds, if we're calling in other creatures who will feast on them, creating a balance restoring a balance in an ecosystem is also helpful. So I'm utilizing those resources as well, and creating our own little backyard habitats, I think is is also really nice, but this is unfortunately what we're up against, right? These kind of invasive creatures. Yeah. So how do we kind of maintain organic matter and build up our ecosystem around us that we have control of? Because unfortunately we can't control others' gardens or trees being removed or deforestation, but we do have control what's happening in and around our own properties, which I think is a beautiful thing.
All right, we have several more questions. We're a couple minutes before noon, so let's see how many more we can get, and if we want to stay on a couple more minutes longer, we can, but let's just roll through these. From Carmela, how do you recommend removing grass and weeds to prepare area for gardening?
I've tried a number of different modalities. So Ruth Stout is not something that I heard anybody talk about today, which is using organic straw bales as more or less a raised bed. So you can actually put rectagonal straw bales over an area and put little holes with compost in those holes and actually grow plants in them. The difficulty being for a lot of people, it's irrigating. So the reason why that's so nice, I mean, you can also just use those straw bales as like benches or something along those lines for a year. And then once you pull those straw bales up, you'll see that the grasses have died underneath of them. Then you can open up the straw and use that as mulch in the area. I also use layering tactic where I use burlap sacks from coffee roasters nearby. I'd be careful to get the ones that don't have plastic twine holding the bags together. Some people use cardboard, although there's some information out there that the corrugated cardboard that we get that make up most of our boxes, that because it has those holes in there, that they use all kinds of metals and insecticides to keep roaches and other insects from laying laying eggs for international travel. So and some of these things can become systemic from what I understand in leafy greens. So there is non-corrugated cardboard out there. If you have a feed store near you, somebody that gets pallets, they have on top of the pallet a piece of cardboard that is a single ply piece of cardboard. Those kind of relationships are wonderful. And then throw mulch on top of that. There's lasagna gardening, which is another one I've used a lot of, which is basically composting in the fall by layering greens, browns, greens, browns, and then topping it off with a nice already finished compost so that those enzymes and microbes take over and break it down. So in the springtime, that's ready to go. And then there's double digging, which I have also used with mixed success, depending on what kinds of grasses are growing, where you actually just dig up that first 3-4 inches of soil and flip it over. And you might need to do that a few times to actually kill it off. The problem being that you're also killing off microbes that are living in those piles of soil. So yeah, those are my most common modalities of starting a garden through grass.
This is the book that Ben was talking about, Gardening Without Work by Ruth Stout. It may be out of print, I don't know, but another more up-to-date version that might be helpful for people is Weedless Gardening by Lee Reich. So it sort of follows upon the principles that Ruth Stout espoused probably about 50, 60 or more years ago. But yeah, basically covering the soil with something that will suppress the weeds.
All right, moving on, question from Judy. What happens to the worms during the winter?
Yeah, so that's one thing you need to consider. My sister is really fortunate to live in California, so she does not have a problem with that. This is where bins like that I currently have are really good. You just bring your, so you can bring your worm bin inside and your household temperature, whether it's in the basement, so long as your basement does stay warm above 60 degrees, or you can bring it in your house. They sell really trendy and nice looking worm bins, so that's just the option. You can also put them into your compost. That's something that people end up doing. So there's a bunch of different options. I just have mine inside. I feel like that's the best way, and they're part of my family, so I get to check on them whenever.
Excellent.
I can,
Oh, go ahead. Go ahead.
yeah, I just want to add too, I have my compost system outside. And when I started it, I added a bunch of red wigglers, and they just kind of, if it's outside and your compost pile is big enough, they'll just hibernate and kind of hang out until the weather warms up in the spring. I think that depends on the kind of worm as well, but yeah, they'll chill out until conditions are right.
Excellent. All right. Question from B. Hallbecker. When garden composting, can we include citrus and onions, garlics?
I do. Anybody else?
Yeah. So I think you mentioned in the worm composting, obviously, citrus can cause your worms harm. They get super thin, almost transparent, fall apart. But in my compost, I'll never make a compost that is dominant by those things. And interestingly enough, you're mentioning all things that are pretty antimicrobial for a time. But if they're bombarded by microbes in your compost, they will ultimately break down, as everything does.
I think it's a balance, right? It's like just being aware of what you're putting in there and the balance. So it's just being mindful when you put something in. Pretty much in life, balance is key. It's difficult, but you got to find that place.
I'll figure that out at some point.
Yeah.
All right, next question. Someone mentioned growing mushrooms in shady areas. How do I start growing mushrooms?
Yeah, I saw that question. Happy to hear it. So mushrooms have quite the number of tiers of difficulty and to produce. But I will just start by saying the wine cap mushrooms are probably the easiest mushrooms that I've ever grown. For those of you that are familiar at all with permaculture principles, where you grow things that require lots of care or that you need to keep your eye on as close to where you commonly travel. This is one of those things. The reason why you don't see it in stores is that its shelf life can be as short as 2 days if it rains, and 4 days typically. But the wine cap mushrooms, you can inoculate fresh wood chips that come in that are not smelly wood chips. Again, pine and cedar and, some of these other highly aromatic walnut, highly aromatic woods, that's antimicrobial properties, particularly antifungal. So you want wood chips that come in that are not, very aromatic. And you can just mix the substrate right into those fresh wood chips, or you can pasteurize them, getting them up to 130 degrees for like an hour or so. Or what I often do, if I have older wood chips, I'll just put them into a giant container of water and let them rot. I'll let them go anaerobic. And that means that all of the other fungi that are occupying those wood chips die. And then I can take it out of that smelly water mix, and it's like a less energy intensive pasteurizing. I can then mix in my my wine cap sawdust. There's plenty of resources online where you can get that. And then if you probably the most amazing thing is once you get it in, most mushrooms require full shade. This mushroom, once it's established, will grow in full sun. It'll grow in your garden paths. It loves being walked on. I put it on all my walking paths through my gardens. It's easily the most successful mushroom I've ever worked with. If you miss a mushroom and it gets all, gross and you didn't harvest it in time, you can just take that and put it in a 5-gallon bucket of water and stir it around, and it has purple spores, and you can pour that purple liquid over your next mulch pile that comes in or through your walking path to reestablish that colony. It's so simple. There's so many others. I do lots of mushroom growing here. We have lots of workshops, and happy to field any questions specifically on that if people want to email me. It's ben@thereedcenter.org.
Excellent. Let's see, moving on, suggestions for grub control from Joan.
Ducks.
And they produce tons of eggs in winter, so that's another great thing about them, and they don't destroy your lawn as much.
Yeah, they drill rather than scratch. And even more than that, they're so cold hardy. The only reason that ducks are typically migratory is not because they can't handle the cold, it's because of food supplies. So as long as they're able to continue eating, which my ducks predominantly eat from my warm compost, they lay eggs through the year, and they prefer not being protected even when we have like a wicked nor'easter with deep cold, and they prefer being out in the snow during the snow. It's pretty wild.
Right.
And their wattles are the cutest. You will
Yeah.
have concerned neighbors coming to your door, though. I battle that in town. So if you are in town, people are like, are you going to provide shelter for your ducks? Are they okay? So it also becomes a great
Right.
educational point.
Yeah, and I will say that they have harmed my productivity. Like they're like a space-time continuum thing where you see them and then you're like, oh my God, that was 2 hours. So yeah, there's that.
All right. Another question. I would love to find out more about the pillar vertical gardens. Do you have a source where I can find this information?
Yeah, so we're just still building the page for the Reed Center. You can go to canyalove.org, which is the first nonprofit I started, and you can see some information. It's really simple. I'm happy to, again, answer any questions about it and send you the resources that I have. It's just fence made into a cylinder, 8 feet in diameter. So 8 feet of fencing connected to itself. If it's tall, you need to have a central support that goes down into the ground. Fill it with compost, and you need some kind of retaining medium. So you need to have a cloth, whether it's weed block, some people use. I like to use straw as my soil retaining medium. And then you just poke holes through the side. The best fencing is the welded wire 4x2 rectangular fencing, rectangular holes in the fencing, because you can actually fit your full hand into that. But it doesn't mean that that's the only one. There's plenty of other ways in which you can do it. And it's best to build them in fall, so you let your soil settle. By the time spring comes around, you can, top off the soil. There's other things you can do to make sure that it doesn't compact down, because when you build, like I've built 8-foot tall versions of this, you can imagine 8 feet of soil, the amount of pressure that comes down on that bottom soil is really compacting it. You can do things like poke bamboo or sticks through it that kind of create different tiers throughout your vertical garden, so that all of the weight is not pushing down on the very bottom soil.
Would this be another way to start actually not a raised bed, but a new garden bed? Could you essentially do that? Like build a couple of these and then unleash it the next year?
Absolutely. I've actually done that in reforestation projects in Kenya. So they were actually, ironically enough, we were doing vermicompost in one, and we were doing regular composting in another, and kind of flipping it. For those of you that are familiar with the thermophilic, like where you flip your compost every time it gets up to about 130 to 160 degrees. And then using it as a garden for a year, and then ultimately, opening it up and using it as fertilizer for the young trees.
Look at that system.
All right, everybody. I think we've run over. We went a little bit late, so I think we'll have some, good ideas on how to restructure the program next year, which we probably should add in more Q&A time at a minimum. But I want to thank everybody for joining us today. Thank our panel members. Thank you again to our committee members. And for those questions that weren't answered, feel free to reach out to our presenters directly. And also we'll send some follow-up resources as well in the follow-up email. And we'll try to get your questions answered for those that weren't answered through the rest of this panel. So thank you, everyone. And be looking for, as I said, the survey, we'll send that out via email and a follow-up as well as a link to this recording. All right. All right. Well, enjoy the rest of your weekend.
Ready.
Thank you, everyone.
Enjoy the beautiful weather.
Get on and plant.
That's what I'm doing right now.